projects and like all the solutions and all. So what we will do is we will call one by one. If you have seen or listened to my that voice note, so there will be three teams per problem statement we are calling. Okay, be ready with your the entire like go with the solution what you have. Don't say that this is the problem and all. They know the problem. Very first thing for the pitching, always team comes, half the time they will dilute for explaining the problem. All the jury knows about problem statement, so straight away go to your whatever you have built it. Means 4 minutes you will have. Okay. Earlier startup elevator pitch for 2 minutes, but here you are getting 4 minutes. Okay, team. Any doubt? 4 minutes and 2 minutes question answer
Arrange
from
them in
jury.
file or staple them, do something.
Okay. 4 minutes. Be ready with your presentation. Who are leading the Type C display? Type C. Who has one? You have. Okay. You have. So one more suggestion. There are two things while you when you use that HDMI cable and all, there are chances that your resolution will change. So keep in mind that whatever your software you are working, it is customized for that resolution also. Usually 16 by 9 we use here. Okay, it's a standard resolution. And if someone is having some problem with the display, so take your laptop to the jury members. Don't waste time. Okay, take your laptop or someone will be there. He will call you and he will show you directly. Anyone will have doubt because Ubuntu will always have doubt while the HDMI and all. Anyone wants to test? Anyone? Mac we have that connector. Windows no problem. Ubuntu also no problem, but there is always having some problem with the Linux. All done? Okay then. Okay. Any doubt, anything? And one more thing, while the jury members is there, maintain a decorum, please. Okay? You will get certificate after the presentation round. And don't take it back like you will not get a chance for presenting and all. You're all here for the learning. The people who are here free, you can learn that whatever you missed, maybe the presentation skills, maybe the display skills, anything like that. Okay? So all the best everyone. One more thing, if someone having problem with their laptop regarding the battery issue, we have a power available here. So get ready with your that particular adapter. Okay. So teams, you have to display your prototype, what you have built it. Presentation you have already did. If presentation is a part of your explaining your prototype, then only you include. Okay? Prototype is must. Straight away what you have done. What are the problems you solved? Straight away put on that. Okay? Bye bye. Right or left?
प्राची वाली अभी हम सुन आपको ऑर्डर करना है
My presentation is not there. If you have something to present via laptop, that can be possible. Yes, sir. Yeah.
Where is Prachi? Just call Prachi and you.
आप जो करेंगे उसे करो मैं लेके आता हूँ yes 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 you click on that so running the show
Hello, hello. Hello. Hello, hello, hello. Yeah, it's fine. It's fine. Okay. Hello, hello.
Agni, who are the volunteers at the stage? Who are the volunteers at the stage? Stage volunteers. So what is it is 20 seconds. Get the paper printed of 20 seconds and someone will show to the team 20 seconds like this. Okay. हो जाएगा जल्दी फाइनल हो जाएगा तो वहाँ पे अरे वहाँ पे चलेगा सो पीछे एक बंदा है 20 सेकंड जैसे ही होगा ना पीछे एक बंदा है नॉर्मल 20 सेकंड लिख दो और ऐसे दिखा देगा 20 सेकंड और 20 सेकंड तो एक 30 सेकंड लिखा होगा पर ऐसे लिखा देगा जगदीश प्लीज रन क्या है Aji ko okay, perfect. Yes. All the teams, Agni or taking care of all the teams, right? Top 3 are there.
Directly with the pen. Both. No, no need of the communicating.
Hello everyone. I hope I'm audible. It's a request from to everyone. Kindly please your mobile phones on silent as duty members will be arriving soon. your pitching starts, at the back there will be someone who will be carrying two timers, one of 60 seconds and the other of 30 seconds. So once you reach your 3-minute time limit, someone from the back will show you a 60-second, 60 written, so that you need to have a clue that you need to complete your pitch in 60 seconds. Okay? The last cue for you would be of 30 seconds, and after that you need to stop it. You need to have a hard stop. For Q&A, you will be allowed 2 minutes, and please make sure you are brief and crisp in your presentation. It is always suggested that you present your prototype, but please keep your presentations handy as well. Any questions if you have got before the jury members come in? I've told you. I'm happy that. Also, teams, one more thing, while you're coming for the pitching session, please make sure your presentation and the prototype are on the same system. Do not make it hassle for the presenters over here to assist you with different systems. Keep everything in one system. Your local host or your cloud servers must be running before you arrive over here. There will be no time given apart from 4 minutes to set up the system. Please remember this.
पहले हम आ जाएंगे सिस्को anyway
because यहाँ व्यू में प्रॉब्लम होगा
so for every problem statement sir Please, whatever is not been asked, it's in the final this thing. Now we have shortlisted the three problem statements in three parts, three weeks each. So now we have to decide on the rest. We are giving them 5 minutes each, 10 minutes each.
4 plus 2
4 minutes. So
4 plus 2 4 minutes
says also.
all set R1
of silence, please. We are gonna start soon. So good afternoon and welcome to the finale pitching of Karnataka State Police Police Hackathon, Academia partner IIIT Bangalore, technology partner Microsoft and Intel. So we'd be having the jury pitching round. Top 3 teams from each of the statements have been selected and they would be pitching. The pitching time is of 4 minutes. Teams would be presenting for 4 minutes, including their presentations or the prototypes. Jury members would be evaluating, and there would be a 2 minutes of Q&A for each of the teams. So that's the segmentation. Before we begin, I'd like to introduce the jury members to everyone. So we have with us Somendu Mukherjee, IPS, Additional Director General of Police, Police Computer Wing, Bangalore. We can have a round of applause for sir. We have Devabrata Das, Director IIIT Bangalore among us. Yes, definitely, sir. Then we have Mr. M.N. Anuchet, IPS, Joint Commissioner of Police, Traffic, Bangalore City. We have Ms. Vartika Katiyar, IPS, Superintendent of Police, SCRV, Bangalore. We have Santosh Babus, IPS, Superintendent of Police, State Intelligence, Bangalore. We have with us Dharmendra Kumar Meena, IPS, Director, FSL, Bangalore. We have Praveen Srinivasan, Director, Customer Service, Azure Data and AI, Microsoft. Mr. Dinesh, Senior Vice President, Faculty. Professor G.R. Sinha, Professor IIIT Bangalore. Ms. Mausumi, Cloud Solutions Architect, Intel. With this, without wasting much of time, we'll proceed with the pitching sessions. So, the first team will be starting with fraud app detection as the problem statement. Fraud app detection, the first team which is going to present is driven by data from Bangalore PES University. Team, please.
Check. Hello. Very good afternoon to everyone present here. We are driven by data, respected jury members, mentors, and all my fellow delegates. Mobile technology is something which has been ubiquitous in every field. It's been growing as much as any other technology. And the scams which have arisen from this field are as paramount to the security of this nation as any other. Our goal today is to provide the Karnataka State Police a self-sufficient, totally self-serving platform, a software which will on its own detect every fraud app which both reactively and proactively and present it as a list to the Karnataka State Police. To do this, we have a mixture of machine learning and a lot of other algorithms. To that end, I request Suhas to please take us through exactly what we're doing before I follow through on.
Okay, so the first part is our code is extremely we made it like extremely modular. So there are 3 main modules: driver 1, driver 2, driver 3. They each have their own specific roles. Driver 1 will scrape Google Play Store to get several apps. So as you can see from the bottom here, it returns a list of all the app IDs which are going to be running against our own database. This database will be like procured from the RBI whitelist. We'll be testing it against like well-known non-fraudulent apps to test them against, and to produce a probability rating score such that we can tell that we are this confident that this app is fraudulent or not. The driver 2 is a module that calculates the score using various ML and data techniques. So as you can see, we are testing for 2 things. One is we are testing for clones, and the other is that we are testing for frauds. So these 6 methods for testing frauds. We're then calculating a maximum score, and for that we're getting 2 lists. One is a list of all the fraud apps, and one is a list of all the clone apps. Driver 3 will be used to create a sorted set of this and make it into a CSV file. This CSV file will then be sent to the police email address or whatever is given to us, and it will be sent over mail. It will be sent over SMTP SSL secure protocol. So for that, we have made our own connection, and to test it, we can actually run this code. And as you can see in my email address here, as soon as I ran that code, we have received several fraud file CSV and the clone file CSV. This is the module 3's job. So the advantage of having 3 separate modules to actually do our work is such that if given a highly powerful system, we can pipeline these modules to do the same work at separate times. So it will be more highly efficient, and it will reduce computation time by a very great default. Now I'll be explaining it. I'll be passing it over to Srinivas to explain the modules of the driver 2, which will explain how exactly the fraud score is being calculated.
Yeah, so I think we just saw how we modularized it so that it's both easy access as well as we can understand clearly what's going on. A couple of things I would like to highlight here is first that number of modules we're doing is 8. We are using 8 modules, and each of these 8 modules will test data, and based on that data, it will produce a probability of an app being a fraud. That probability will then be placed as a weighted. It will be placed as a weighted average. We will give a weight to that probability based on its importance, and we will give a weighted average to that probability. We will then find the weighted average of all the probabilities that have come from each of the models, and find one total probability, which will give us the probability of it being a fraud app. This probability will then be sent to the police as an SMTP, as he just explained. Yeah, so that's what it is. Positive time.
The time is up. If the jury members will allow, I'll be. Shall they continue, sir? Yes, sir. Yes.
Thank you, sir. We'll take 30 seconds. Thank you very much, sir. We'd like to open for questions as well. Sir, I mean, I think I mostly said what I wanted to say. We are using, there's heavier sense of machine learning. And I think I mostly convinced that we are open to take questions if you'd like to. Sure, absolutely. So this is the final email CSV file that will be received by the Karnataka State Police. So they'll have this app ID, which will be the ID which every app, it's a unique ID for every app. There'll be a reason, which is basically the most. This reason is calculated by the most. I told you about the 8 modules. The module which caused this is the reason, and the probability of it being a fraud app. Now we will set a cutoff for this probability, and if it's above that cutoff, we will recommend that the Karnataka State Police takes action against that app. That's how we are working. Then similarly, we have something for a clone app as well. It's a test number, sir. This is how it will look like. This is an example test case that we ran just before. Because of the size of the data and the lack of the computing machines that we have, we cannot run it live here. But this is an example that we just ran before this. And you can see these are how the probabilities come. And since all of these probabilities are below 0.6, which we have set as our cutoff, we have arrived on this list. And therefore, we will recommend that the police can take action on these. Sure, sir. So, sir, this you can see. So one of our models, I was going to explain the model, but due to paucity of time, I couldn't. One of our models checks the description. So many of the times, what you've noticed is that 2 apps, they just copy the exact same description and they call themselves a clone. And they call themselves a separate app and try to cheat the citizens. So to do that, we have a description checker wherein we scrap this description, and you can see this is. Can you just scroll up? This is the Grow app, and this is a clone of the Grow app, which our model has found. So this is clearly you can see this is not an official Grow app. It's some company, but they have the exact same name. They have the exact same description, and that would lead any unknowing citizen to believe that this is the actual grow up. But when in reality, this is the actual grow up. So this is the sort of thing our model immediately discovered. So this is the sort of thing that we hope to eradicate with our model. Of course, sir, we provide a probability for it. So I mean, if it's above a certain rate, we'll flag it as.
How accurate you are in this probability?
Our review model is 90% accurate. We have trained against all the RBI whitelisted apps. So if we increase our data set, we can increase accuracy even more. So we are hoping that we can get more non-fraudulent apps to train our data against, to train our model. So as of now, it's around 80 to 90. There are several models. On average, all these models combined together have around 80 to 90%.
So just one more point that I'd like to add is in the beginning of the conference, we heard Sandhu sir actually talk about NFBC, which is non-financial banking companies. And we have implemented that to make sure, because we heard that RBI has recently backed these NFBCs. So we implemented that NFBCs and we actually check in our algorithm if it is backed by an NFBC. And we also check the APR. The government of India has regulated that the APR is less than 36%. And we have checked that as well. So these are two other things. And every app that we compare with is against the RBI whitelisted apps. So it's on the official RBI page. It's hard facts. It's not something that we are just taking out of thin air or something. It's hard facts. RBI has issued these lists, and we are comparing. All our models are trained based on those. So that's how we train our models, and all our accuracies are based on those numbers.
For clones, it's set as a similarity matrix. For example, for our clones, so for fraud, it's a probability, but for our clone, it's instead of.
So that example was of a clone.
Yeah, this is an example of a clone. This is what I think.
Solution has thrown up.
Yeah, one.
In the solution that we provide, we will provide a separate CSV file which will list out all the clones, and a separate CSV file which will list out all the.
We have already shown clone.
Yes.
The fraud can be shown.
Yeah, sure.
So this was our first ID that we came, and the reason it was flagged was because of its developer, clearly a Chinese corporation, and the website was not mentioned anywhere, and even the reviews were not all, like, they had very low ratings, and most of them were negative reviews. This was our semantic review that picked this up, and we had received a very low rating on this.
So just continuation of that, our one of our models is semantic review, which basically sees the the sentiment of the reviews which are there, and it highlighted that app which he just showed as a very negative app, which basically meant that the possibility of it being a fraud is very high. And it turns out when we actually went to that app and saw it was by a Chinese developer, and it's also an app which has also been flagged by the RBI. So this is another example of our app being able to detect.
How you make your how you define your probabilities with respect to the fraud categories? Because it's difficult.
Okay, sir. So, sir, can you repeat the question, please?
How you define your probabilities versus with respect to the fraud categories?
Sir, so basically, we have a machine learning training model, and based off on that, we decide the probability. That's how.
Don't put it into the black box called machine learning. Define that now, because we are writing the-
Sir, I'm sorry, I'm not able to understand exactly what you're asking. No, ma'am, it's dependent on 8 different models, and each of them. Okay, I can. So the 8 different models. One of them is review. Review is one of them. Yeah, I can show you. Can you just open that if it's possible? So the 8 different modules are: we check the reviews, we check the information about the developer, we check the rating of the developer, we check the different metrics: how many people have downloaded it, how many people have enjoyed it. We show the versions. We have noticed that fraud apps generally do not check versions. They do not update themselves. So we have checked their versions. So these are you can just see this description is basically checking this fraud underscore DESC checks the description. it compares a description to find the clone apps. This fraud underscore DEV, it compares the developer. Basically, it finds more about the developer. It finds, does the developer have any other similar apps? Are those apps blacklisted or something like that? So each of these fraud reply is basically, fraud apps generally do not reply to comments. If there's a comment, they do not reply. Right? Many other legitimate apps generally reply. If there is a problem, they reply. So that is also another thing that we have considered. Yes, ma'am. So each of those is a different module that.
I think this is a great way to shortlist a set of probably fraudulent apps. I think there's a question that comes in.
Sir, I don't know if that was a question, but if I may. Okay. Yes, absolutely.
We are also working on, we also tried working on APK, so if given an APK file, we'll be able to get into the code of that APK and try to decide whether it was a fraudulent app or not. The only breakthrough we got into this was discover whether it had any malware. We weren't able to exactly discover whether it's fraud or not, but we were able to discover whether it had malware or not. Also, we were only able to use it using command prompt. We were not able to integrate it with the script. So that's why we did not pursue this into a more deeper thought. So.
Thank you, sir. Thank you very much.
Thank you, team driven by data. The next team from the problem statement for app detection is rebooting rebels from Bangalore, from IIIT Bangalore. Team, please.
Greetings to everyone present in this room. I'm Adrit Sharma. Yes. Greetings to everybody present in this room. And I am Adrit Sharma from IIIT Bangalore and here to represent the team Rebooting Rebels. We have come up with a solution to the problem of detecting the fraud loan apps on Play Store and App Store. And what we propose for that is a dashboard which will give us on searching a keyword and giving a date, all the list of possible and the most the most possible fraud apps which are present on Play Store, which were updated on or after that date up to this date. So let me show a demo for that. And of course, what we have hard coded here is that if even we search for keywords which are not related to finance, it will show apps only which are related to finance. Suppose if I search elephant, cat, or anything else, then the apps associated with elephants as well as finance will be the ones coming up, because this was a finance related problem that was some bit of hard coding that we did. Okay, so let me go ahead with the search. Yeah. So the possible fraud apps which were given were two of these, and the possible fraud probabilities of these were 0.63 and 0.5 respectively. We can even generate a report of all the fraud apps which were uploaded or updated on the Play Store after the given date. So this is a PDF for this. And what another solution to the problem that we propose is that we'll dynamically be sending emails to the registered police official as and when we find a fraud app, a possible fraud app on the Play Store. This is not implemented because for this we need a dynamically running website. But of course, we'd like to we'd like this to happen. Yeah, so part of our solution is checking for a URL, where a URL is given as an input, and from that URL we extract all the information that we can, and that URL has to belong to a particular app on the Play Store. From that we extract all the information that we can and say whether it is fraud or not, depending upon the probability scores and some of the parameters that we have. So some of the possibilities I have already checked out. So this is, I think, a fraud app. So there was no spelling mistake in the description of this app, as the parameter says that it has surpassed it pretty well. And the people who were trying to cheat were pretty smart as to not make a spelling mistake at least. But they failed on the making of an email that was legitimate enough to fool us. They probably would have come up with a Gmail or an Outlook account, which again is unofficial, because every financial lending firm should have a proper domain name. It cannot go on with Gmail, Outlook, Yahoo.com. And this was the most legitimate method that we found for detecting any fraud app. And this is pretty easy to scrape from the web. You just have to go to the developer's information, developer's contact email. You get the Gmail account and whatever information you want. That's pretty easy. And even somebody, if like I make an app and say that my developer email account is at the rate sbi.loan.com. In that case, also, I am trying to check whether that email account is legitimate or not by sending an email and verifying whether the existence is there or not. So that's all about the demo of the app. Let me come up with some of the scalability possibilities through which we can make it an industry-ready product. So the data set that was required for coming up with the probability score, that was handcrafted by us. We took out the fraud apps from the internet, we took out the legitimate apps from the internet, and made a data set of our own. And then we trained the model on that. But the parameters like spelling checking, Gmail, and the legitimacy of the uh, email account that is given on the Play Store, and the other things like the commits that are already existing, we can even skip that part of data set dependence. We can come up with a solution which is not requiring any data set. So that is where I claim that this solution is slightly more feasible and scalable in terms to the industry. The lack of dependence on data sets. Yeah, so a business feasibility, which of course most of us already know, is that we can serve this as a software and distribute it to the local police and all the law enforcing agencies based on any mutual agreement of any kind. The funds which are actually being surpassed to
Being the
Chinese
time is
GDP.
over. The time.
Okay, yeah, just 1 minute. Yeah. China's GDP is what is getting India's hard-earned money, and that will, of course, be stopped if we start detecting all these apps right on the go. And the number of investigations that have to be carried out for stopping these apps and to actually fraud the like catch hold of the fraud people, that will also require less effort and time with the help of this solution. The problem of a clone app. Uh, okay, so this was more or less, we did not specifically look at it, but the solution that we have proposed more or less is able to solve a problem like that. We are using machine learning, or we have trained our own data set for coming up with that. Mm.
Eight different parameters. So what are the different parameters that
Yes, of course.
the chances are more? No?
We were talking about yeah, so these are only four which are visible to us. The last line, which is not which is having a lot of mathematics behind it, is not visible. So there are a lot of things like description and the reviews. The permissions play a lot more important role here, because the app permissions, the permissions which it demands, have a key role, and they form a vector together, which can be a good training data set for our model. Of course, yeah, you're right on that, sir. But that is of course. But we have taken care of some specific permissions, such as a gap. This permission, we have other parameters like description of the app, the reviews, and the in the permission section we have, apart from the regular ones like storage and camera, microphones, we have a section called others. From that, we extract using natural language processing a whole lot of features, and that's around like a vector of the number of columns that we have is around 1,20,000 for that. So these five or six permissions may have an impact, are having an impact, but the dominating things are description and the reviews for training the data and coming up with the final probability score. So you're asking how am I coming up with this list of possible fraud apps? Yeah, so I am collecting using an API. I collect all the apps which have been related.
Run a search like what will be the final output for the end user,
Yes, sir.
and how it will be helpful to us.
Yes, of course.
And show us the report also which is sending over.
Yes. So what we do is the algorithm says that we collect all the apps which are related to finance and have been updated on Play Store after a particular date, which is this date given as input. And then we run our algorithms like the checking of the email account, the natural language processing, and the machine learning predictions. And on that basis, we get a score. We have a threshold on that score. And on that, the apps which say that the possibility of which being is greater than that threshold, we say that those are fraud apps, and we are able to generate a summary or a suspicious list of apps from them.
Uh, so this one of the app money app can show it to us that how correct the result is.
Money.
Which apps?
Yeah, this one, I think the last one, no? Money tab, credit time. Money app, right? Yeah. Yeah, so it does not follow RBI registration policies. It does not have an NBFC in its description, which is the previous team also mentioned about it, that RBI has given an official list of NBFCs, and at least one of them has to be present in the description of the app, else it is not can it cannot claim itself to be legitimate. And of course, there are some comments which say, Yeah, whitelisting. Okay, so hmm, hmm. Yeah, so again, this is counting towards a possibility, ma'am. Like if there is an NBFC, we say that this is correct. If there is not, then we say that it is not present. Yeah. Yeah. Yeah, 0.26 for it being a fraud app. Hmm. As of now, the threshold that we have set is 0.20. And probably the mathematics that we are following is we take a weighted average of all these four parameters and we take a weighted average of this probability score which the ML is giving. And from this, we come up with the final score. And that is what is being displayed here. 0.26 is that value. Yes.
Can you show the code for comment checker?
Uh, Sir, please.
Comment checker.
Comment check. Okay, so comment check. If
Code दिखा दो.
a code for the comment check. Okay. करियो type करियो. Check comments. CO. Yes. So, sir, what we are doing is we get a list of all the reviews that are there on Play Store. We find words like fraud, fake, thief, cheat, and synonyms of these. We try and match them with whatever sentences and words we can collect, the relevant words that we can collect from that list. And if at all they are there, we say that this at least this check has failed. Review of the review has been given by the user in that case. Yeah. Okay, so you are saying that there is a rating, but there is no comments as such. So at least in this case, we are only looking at the comments. But this there is something like what we say. Uh, Yeah, so check comments thing is also taking care of, sir, the reviews, the rating, sorry, that you talked about. If the rating is very less, then also we say that the app is not trustworthy or it is fake. And the threshold that we say for that is 2.5. The API that is giving us the list of the apps, the APK. Oh, okay. So if at all somebody who goes out to take a loan from an APK, sir, we tried that, but that did not seem to be working at all. An automated script for running the code and seeing whether it is able to ask for a commission type of a thing before even giving the lab that before even giving the loan. That was what we had in our mind, that we are able to somehow fetch an information that would tell us that this app is trying to get a type of commission even before the loan is given. And if at all it is trying to do that, then possibly it's a fraud app. Yeah. So the permissions thing was done, but even the legitimate apps do that. So theft of data is something that, at least in our knowledge, we could not take care of. Fraud, fake, thief, cheating. Yeah. Yeah. We have the NLP code, sir. Let me show that. What we were doing in No, NLP is based on scoring. That is, a pre-trained model is used for that. We train a model on the the data that we have collected. That's around 60, 65 apps. That pretty small data set, but we have maintained a balance of fraud apps and the real apps in that. And on that, we perform NLP and all sorts of machine learning and end up with the best probabilities using a stack of random forest classifier and logistic regression. I can show you the code for that, the training of the model at least. Finally, we get the model which is trained. We store it, and ultimately we use it directly for the prediction of the new app because we cannot train it again and again on the same data. That is wasting of time.
Yeah, thank you, team. Thanks a lot. Moving on next, we have a change of order for the teams. So the next team is from AI face detection. Jury panel, it's a request for you. The next team is okay. Okay, okay, okay. Okay, ma'am. So the next team that we have is from fraud app detection. The team name is Anti Pirates. They are from Bangalore Comvault. Team, it's a request, kindly be on time and complete your pitch in 4 minutes.
Good evening, friends. This is Team Anti Pirates. Myself, Aniket Prabhu. We have Vishnu here, Vishnu, who is my friend, as well as two people who have joined from online. That is Misha as well as Ishan. So our project, right, it comes under the fraud app detection category. We demonstrate to you. Further, along with detection, right, we went a step a little bit further into fraud app deception also. So keep your eyes on this. We will speak about it also. I will give you an overview about what our product is about. Project name, we called it as Vanchane because Vanchane is deception in Kannada. Our primarily what we do is our target apps, which are distributed across the Play Store, web apps. Also, we have included these as the target platforms. We would collect data. We would collect data using API from all these platforms into our project portal, and we would further proceed to processing it for detection purposes. Firstly, for detection purposes, scan up from the security ecosystem. What is the security ecosystem? It is a conglomerate of all antivirus contributors as well as government institutions who flag for any malicious or suspicious websites, any hash or any APK. So we utilize them. We utilize help for for making this kind of a scan up first. This is the first parameter. Secondly, permission benchmarking, which is take some regulated applications like Yono, for example. Maybe it provides all facilities, may not be best at app this thing the user experience, but provides pretty much everything, right? Sir had also mentioned that permission, if something asks for more permission, then we can't really call it suspicious. True, which is why we go into the behavior analysis part also, which is repeatedly asking for permissions, right? And reuse of permissions. That is why permission benchmarking is important. Validation from legal resources. Our friends also have mentioned, right? Referring our mentors also uh, suggested use of these resources. That is why we refer to whatever is there in the legal sections and check if those apps qualify and come under that category. Sentiment analysis using using the reviews that are there for an app, uh, and with further, with all of this computed, we assign a security score for the application. And the technologies that we're using is MySQL and Azure. Store the images or whatever of the Play Store on the blob storage as well as Python. Next, right, we present it in a dashboard portal for further reporting as well as insights. for the law enforcement agencies. This is the detection phase. Next, I'm coming to the feather in our cap, which is the deception. Deception, right? For example, detection. Police takes down an app. It is not too hard to not bring it back up, right? You can always create a new app and publish it further. So what we want to give is some forensic data for the police to catch hold of that culprit. That is why we have come into the step of deception, which is we will install those fraudulent apps. Even before they go down, we will install it in our subsystems or in our lab environments. We will populate some data into them. What we are going to do is we'll give some lab or some phone numbers into these kinds of apps so that we can actually lure those people to call us up. We can lure these fraudsters to call us. And when we lure them to call us, when they call us, we are going to respond using AI voice. Using artificial intelligence, we are giving a response to that fraudster by collecting their, for example, a fraudster calls me and an AI voice is responding. We are collecting their voice for recognition. We are getting their phone number for tracking purpose. Further, we'll also try to deceive them further by maybe asking them to share, say, if they ask us for my bank details, the AI voice will say, hey, I cannot share my bank details. Can you share your address? I will send a DD. These kinds of deceptive tones. And also an alert is sent to the police when the phone call is ongoing, so that the police can also join this conversation to take it further, so that we can catch the culprits. All of this is once again presented as forensics in the dashboard of our product. Quickly, let's take a look at the dashboard.
Team, the time is up.
Sure. Okay. A quick dashboard overview, not 100% integrated, but hosted on Azure. This is the overview of what, for example, this is what we call as decoys, which is the traps that we set on the fraudulent, those which have identified as fraudulent or detected as fraudulent, which step into this category of deception. Also, for example, one of these categories, what you see here in these color codes, right? This last category is suspected apps, right? This is a could be suspicious. Next is the threatful is must take it down. Last is has to be done, has to be taken down. Those are the threat categories for us. And some of the applications that not fully integrated, once again, what these app details are showing you is the sentiment analysis and the fraudulent, maybe the people who call it fraudulent, ratings or reviews that say call it as fraudulent. Our portal will also generate and share reports to the dashboard, also finally reporting it to the Ministry of Technology, right? That can also be done. Also, you might see this interesting thing called a scheduled run. We do not do, we give the option. Our mentor suggested us to run it every 24 hours, the scanning. But sometimes the splurge of activities can happen quickly. If there is a 0-day vulnerability, it can happen quickly, right? That is why we also provide an option to do an automated scan, which is we will determine based on the number of activities that are happening globally, we will determine the scan, and it need not be more time, then maybe we can demonstrate that AI voice part also. We have captured it as a video. Shall we go ahead? Yeah. Yeah. Was recorded. All right. I think the sound is not connected. But pretty much what it's doing is it's elongating the conversation. The AI voice is elongating the conversation so that we can collect forensic data like voice recognition, submit it to the unified data, the project that is there, right? We could submit it over there, the phone number, so that we can catch hold of the culprits, as well as we can plug in the police when the conversation is ongoing into the call. Yeah. Yes. Correct. Last category, something is where this could be taken down. Should be is which we have received a phone call. We have received a phone call. We as a part of this project, we could not integrate it completely. Yes. Threatful app we have done. Yes, based on the security scores which I described you, right? Suspicious. Yeah. one of them we could at least identify, which is maybe if you can open the last tab on the left side. This is an application we could find for visa application. This fails the category that comes under security ecosystem. It is flagged as falseful. And then behavior analysis also. If you look at if you scroll down a little bit, can you scroll down? These takes inputs which are not mandated and not validated. This is why behavior analysis this fails that category of test, and hence we would put it in the category. He was behaving as a fraudster, and AI was responding. Maybe if possible, just play it tiny. I did hear something.
The mic. Hello, I am Vishnu. I am speaking to the mic and the voice. Yes, tell me. I am from Financial Services Department. And
Volume, you can
volume,
increase the
right?
volume.
No more.
That
This is the full volume. Yeah, which logo you want to activate? So can you personally hear
No,
it?
no, show there. We have seen it.
Fine. So certainly we'll maybe share a video of this, and if time permits later on we can further share it. Yeah. Commvault is into data management. It is a data management company which basically manages storage for the company. He's an intern. I am an employee. Yes. Commvault is into enterprise data management, not into end users. Commvault as a soft because many people might not have known what Commvault is because it is not for the end users. Only large enterprises use it for data backup and storage purposes. Hmm. Data analysis, but not for end users, not for yeah. Fraudulent, yes, right. Fraudulent. I would not say fraudulent. Maybe some benchmarking is there, right? CIS benchmarking, which, for example, you need to ship a hardware. Which one? Voice one, yes. Voice one, it's using Microsoft Cognitive Services. Correct. By novelty, I mean if you can determine if it is unique, right? Our prime purpose is voice recognition of the fraudster and getting the location of the phone call. That is the prime purpose, which is why we have done some bit of existing whatever is already there. We are trying to elongate the conversation as much as possible. That is the prime intent. So cognitive, yes. Right. Cognitive services by Microsoft. Right. Yes. Yes. Correct. Correct. We will yeah, of course we are using it just for recording, submitting to police for forensics. That's all. Yes, correct. That is why. Along with voice, what is additional? There is the phone call is there, right? Phone call comes from a geolocation. We will attempt to track that geolocation, store it, and submit it for forensics. Exist. Yes, existing APIs. Correct. Hmm. Yes, pretty much. Yes. Yeah. Hmm. Hmm. Correct. Hmm.
where actually they make calls to customers or potential
Hmm.
So what you are going to address
Hmm.
by your solution is only one fourth of the total set of problem which was given.
Hmm. Okay. Okay. The deception part, isn't it?
No,
Uh,
no, I'm saying, did you get what I am trying to say? The problem statement has two parts,
yes.
the fraud and fraud.
Fraud.
Did
Okay.
you get it?
Correct. Okay. Okay. Hmm.
There are apps, applications which doesn't have any
Phone call.
calling
Okay.
facility at all, or
Okay.
they don't
Correct.
deploy it
Ah.
as a tool
Correct.
to belong.
Understood.
So you are left out that also.
Ah.
So basically, you are targeting only 25%, 20 to
Hmm.
25% of the total problem.
The detection category is also there to withdraw those apps, to take down those apps. Definitely that is there, as I might have mentioned in the slides, right? The detection category is there. Once detected, we proceed into deception.
That
But you know,
great
it's not ready, no? We cannot find out whether it's
Yes.
good, bad, or
True.
whatever.
True.
because
So,
yes,
sorry, sorry.
Yes, so time was mostly spent on so could not do the integration much.
thank you.
Thank you,
Can we
team.
go to the
Thank you. Okay.
Yes, sure.
first slide?
Santosh.
यहाँ पे वो नो पहले वाला just what you just showed. Yeah, next
Next time.
next. हाँ यहाँ पे वो scan up from security ecosystem है.
Correct. Yes.
Can you go to the code?
The code. Okay. If you can look through the.
Asian legal process is very easy. RBI and SEBI websites were done. Security score is fine. Behavior learning is very interesting.
Yes, sir. Oh, it's not visible. The PPT, if you will need to withdraw. Close it. Yep. The ecosystem, security ecosystem, the virus total. Correct. Yes, virus total. Behavior analysis using Selenium, a tool which is to automate the behavior, automate the, or rather to test an application, right? We will launch an application, attempt all the operations that are there within the application, keep on monitoring, the behavior of this, or rather say the activity of that application. For example, if it request open our lab, our lab will do it.
जो जाने वाला है कौन जाने वाला है
Can you only scan PPM? So, how many are
Yes.
listed or
Okay.
पूरा देखा हो आपसे क्या
This is one of the result that we got from virus total, which the application which I showed you for UK application, right? That app, the web app. Here you can see two of them have just now, two of the security ecosystem people have marked it as malicious at the moment. Based on that, we are putting into the red list category. for now, yes, it is just as like this. We have not integrated into the dashboard report part. Sure. Thanks a lot, everybody.
Thank you, Team Anti-Pirates. With this, we come to an end of fraud app detection. It's a humble request from the jury panel to please complete the evaluations for the detection. And if the team, if we could collect the seats. Moving on, the next problem statement that we'll be covering is AI face detection. And the first team for AI face detection is the Codebusters from Thadomal Sani Engineering College of Mumbai.
Hello. So good evening, all. We are Team Codebusters from Mumbai, and today we would like to present a solution for the AI face detection problem statement. So this is the website portal that we have made for the police, and we would like to take you through it. So basically, in the website, we have provided a solution for two portals, which is reporting a missing person and finding a missing person. So reporting will be like a submission to our training model, which will be performing the analysis, and finding the person will be checking on the status of the report that they just submitted. So now we submit. We'll check on a report that we previously submitted in. Yeah, so this takes some time to run because it's going through all the images and everything. So by that time, I will take you through our homepage. Yeah, so basically, this is our homepage, which lists some basic details, the features, etc. Can you scroll down? Yeah. Uh, these are some basic details and contact us, etc. Okay, so we have also provided provision for two portals, which is submitted cases and confirmed cases. In submitted cases, the police officer will be able to check all the cases that they have submitted but not received a response on yet, a positive response if the person was found or not. And confirmed cases is all the cases that they have submitted and received a confirmed response that yes, this person was. Yeah, so we also had an idea that to improve the accuracy of our AI model and to collect more data on images, etc. We proposed a solution of crowdsourcing from the citizens. So if the police is flagging some people as suspects or missing people or terrorists, if a citizen feels that they have seen that person, they can click a picture of that person and they can submit it, which would be sent to our database, and we would also use that to train our AI model to improve our accuracy. So this is also something that we have done. Okay, so the report that we submitted in the start has finished, and this is the final report. So we have the image of the person, we have the prediction accuracy and the verified status. We have some social media links of the person, which is Instagram, Twitter, LinkedIn, Facebook, Pinterest, etc. And another thing, sorry, so another thing I want to talk about is that what we've done here is we've taken the current image of the person and we're providing a progression of how the person will look in the next 10 years, in the next 20 years, or how the person looked past 10 years to give an idea to the police of the other faces that they can look out for of the same person. We're also providing a picture of the person with a beard on.
Okay, so this uses a GAN-based network in order to predict. The parameters, as you can see, so these are all customizable right here. So yeah, as you can see, like 4 or 5 images are with beards. So these are personally customizable. Suppose a person is being missing for 10 years, 20 years. The police can input the value 10 and 20 years, and via the input image, can you go to the input image? So if it gives, I want to see the picture last 10 years, it will get predicted and you can see the past 10 years of the image. Also, one thing, uh, during missing person, we only have usually one missing case, like an image or stuff. So the question arises, how do we deal with this? So if we have only one images, we use a method known as augmentation. So using that one image, we take different angles of that image, like we crop the image, we increase the brightness, so that we increase the data set artificially. This in order increases the accuracy of the model for classification of the label tags. Thank you. We are open to any questions. Yeah. Yeah, these all linked lists are being crowd. So we run a scraper through Google, and the first links that name. So we give an input tag as a my name. So that's sort of background, right? So this works real time. We could show you if we can input your name and show you too. We can show you a demo if you like. Okay. Yeah, yeah, yeah. Yes. Uh, as in that, so it's like 83.8%, right? Yeah, yeah. Uh, I don't. I don't understand the questions. No.
Ethan's at low accuracy. I drank.
So for this detection, we have used Siamese model-based networks, which is a convolutional network. So initially, the data set that we were provided with was just 500 images. So we didn't consider that data set. We chose a new data set which has 15,000 images. So how a Siamese-based model works is, no, we coded it from scratch. The Siamese-based model, we trained it ourselves. Yeah. Can you show that? Yeah. So currently, when we input an image, yeah, we have gone through image processing. Yeah. So once we take the input image, so how a Siamese-based model works is basically we first train the model with using the 15,000 images. So using that memory of 15,000 images, once I input the train and tell, usually it just takes the points on the face, which are known as face weights, and it calculates the Euclidean distance towards the faces. Yeah. Yeah, so a Siamese-based model basically, we take the first 15,000 images, we train the model, and then after we train the model, we split the incoming data set into three categories, which are positive, negative, and anchors. The negative consists of the 15,000 images that we have already trained with it, the Siamese model. So basically, it's just two ports becoming into one port, and the loss generation is basically through distance. For the data set, we have used celebrity data set. So we actually tested a data set through Indian faces also. So we were getting like similar results during it because the only thing that we're calculating is points for faces, right? Any other question? Yeah.
The synthetic images.
Yeah.
Synthetic pictures are a person.
Yeah.
So for testing, if you provide one of the synthetic image as the input, will it work? Will it
Yeah. So
work?
suppose we don't know what the user will look like in 10 years, right? Yeah.
Very relevant for criminal investigation.
Yeah, that's true. So
There is a change in the appearance.
yeah.
So will
So
it be considered as a valid input?
yes, it will be considered as valid.
Have you tested that?
Yeah,
Have you given input as, can you demonstrate that? Have you given one of these synthetic images as the input and you brought that back?
So one of the scenarios that we considered is, suppose if a missing person has been missing for over 10 years, but we find him and he suppose he has a beard all of a sudden. Let's just say we input the parameters of the beard in there. Once we use the same model and we process the image back into the data set, we see that the accuracy still remains the same and the person is detected. We have tested this.
Answer what?
Excuse me. Yeah. See. Oh. Yep. Yep. Please. Yeah. Whole intention of this problem statement is to search the basically people by image. So I think you are running search by name. Is it or like how it is?
You're talking about the profiler or the social links. Yeah, so the social links are on the basis of the name. It's not on the basis of the image. But the AI model is obviously on the basis of the image.
No, we have ourselves taken the architecture of Siamese and we have implemented ourselves. Yeah. Uh, yeah. Uh,
So we have wrote our own scraper, and also like we don't have reverse engineering for image to finding the social media links for the person, but we were trying that. And also we have designed an API which does all this. So every prediction and everything is done through a API. So there's only one system controlling the whole thing.
That is, the facial feature should be the identifying feature. And you have to match it with the facial feature of the photograph profile, DP, and profile picture of any other photograph which has been uploaded in social media. So to that extent, your idea is completely detached from what the problem statement.
So, sir, I completely understand what you're saying, and we did try doing the image thing, and we ran into issues doing that. So, we came up with the solution of crowdsourcing for that. Because what you're talking about, that's right. We need a large database. We need more images to get better accuracy and improve the technology. So that's why we propose the idea of crowdsourcing to find the person quicker and more accurately. So we're basically taking multiple databases, police database and the crowdsourcing database and multiple databases like that to run our AI model. So we're focusing on that more than scripting because we couldn't do that in the way that was expected.
And also now that we have links for the account, so then we can process the profile pictures and all other posts. Thank you.
Thank you, Team Codebusters. With this, we move on to the next team for AI face detection, that is Shadow Lovers from IIT Jodhpur. Please welcome Team Shadow Lovers.
You just have to go to duplicate. Search duplicate. Duplicate this. Okay. Show only on two. Oh, show okay. Duplicate should work, right? Can you go to second screen only? Can you go to second screen only and check? Yeah, I think.
I think this code is not okay. No, I don't.
Okay, can we open our my laptop and we'll just. Yeah, we'll just sort of brand demo. Hi. Oh, thank you. Hello everyone. Sorry for the delay. Yeah. So we are team Shadow Lovers, and our project name is Godjai. Literally. So project is based in six techniques, basically detection, face attribute enhancement, aging image generation, similarity search for finding similar images, similar people's images, face attribute edit, that is changing the facial qualities like hair, etc. Sorry about that. And then integrating our algorithm with the UI. UI is made with Unity. So this is our UI, the first phase of it. So here, this is a selectable tile block where you just have to right click and select an image which you want to search with a repository. I mean, search against a repository to find a matching image. So here, once you've uploaded your image, it'll adjust for skew and it'll detect the facial features alone, the crops basically, and then it'll restore the face. So then it'll, if there's blur present in the image, it'll deblur it. So it's a it's a GN based deblurring and face enhancement processing that happens here. And then we'll have a repository in which we'll compare the image embeddings, basically features to identify similarities. So here are six images that are present in our repository, arranged from the closest pair to the image to the furthest. So one, two, three, 4, 5, 6. That's the arrangement. This is Salman Khan. So this is an image that was given to us by the Karnataka State Police. So it was part of the data set. So uh, this is where we apply some facial attributes like changing the hair, slightly modifying the face with like removing slight portions of beard, etc. And also we have 8 different hairstyles that we can opt for. So based on which one is uh, probably a different, let's say, fake appearance that they are providing. A similar appearance where the hairstyle is different for that particular person. Here you can see the image is slightly blurred here, and it's pretty sharp here. That's the GAN model working, providing enhanced image, and that's the result on the enhanced image. Yeah, yeah, sure. Oh, it's you're not able to move. Okay, you can show the demo then. Okay, we'll launch the EXE and we'll show you a brief demo of how the tool works. So this is the tool. We launched it. See, we are browsing. So we're gonna pass one image. Yeah. Yeah. So this is actually me from the hall. This is the detected face. It's slightly blurry, and I think because of the resolution, it's a bit dark, but it's actually not that bad. So right now, yeah, you can. Have you clicked search offline? You can click search offline. Yeah. So now we are checking with the repository right now. So the processing is going on. The repository consists of around 500 images, and we've added our image as well to the repository. So similar to the Salman Khan image, there'll be 6 matches starting from the closest to the furthest. Yeah. Yeah. So okay, there's a problem with the port. Doesn't matter. So this is me, the straight version of me, and that's also me. And these are the database that was images from the database that was provided to us. So these are the 3 features. Restored face is this one. You can apply age filter also. Uh, we can change the image and we can process it. The problem is the monitor is not working for him, so he's having to look at the screen and move the mouse. It's a bit challenging for us. Yeah. Uh, okay. I think it's down there. Hmm. Yeah, it's that. Okay, it's like mirrored. Okay, just have to move it up. Uh, yeah. I think if does anyone have a mouse with them? Can we borrow it for a minute? Uh, yeah, got it. Thank you for the encouragement. So yeah, here's another face from the database. Can you see the image is quite blurred? And this is the enhanced image, GAN model that returns an enhanced image, which is pretty sharp. And then we can use any of these images. Yeah, you can go to the edge filter. Yeah, the wrinkles are enhanced basically. That's it. Yeah. So both the generator models are GN based. So API. Yeah, we have eight different options, so we can have eight different hairstyles for the person. Now I explained about the three features, which is restoration, age filter, styles, and the next part is where we browse the web. Next part is where we browse the web. So we use Selenium to web scrape. So we're not going to use image embeddings to search online. We're going to use their names, but we're also going to use their image embeddings to compare and verify and arrange. For example, this is a friend of ours. He's part of our team. So this is Deepan here. This is the reference image which we're using to browse. And we know that his name is Deepan. So can you go to the browser? Uh, yeah, this one. So this is the images folder in Google with his image as well as a lot of other Deepans. And there are also images which don't have faces. If you have a look at here, there's a logo. There's a logo there. So what we do is we extract a set of images from this particular page, analyze if there's face present or not, and then if there's a face present, we're comparing it with Deepan's test image, and if it matches, we're going to sort it. You can go back to the plot. Yeah. So this is the plot where this is the image that we are comparing. These are the images that were available online in the Google web page images directory. So let's match second match and the last one, which was not him basically. So we used Azure for Azure Virtual Machine for web scraping. So it was we deployed there, and we'll get the folder and we'll add it to our database basically. So the more data that we have to compare, the better our results is going to be. So right now, within the stipulated time, we are able to match Deepan with his particular repository. So if there's any other person that's required, and if we have permission to access folders from different websites, private images, or yeah. Uh, so uh, okay, so if it's blurred, we are in. Okay, understood. Yeah. So if it's blurred, hmm. Yeah, exactly. Yeah, exactly. So we are basically enhancing them. We're not going to retain the features. We are enhancing so that yeah, we are enhancing so that the clarity is better.
Yeah, but let's say you have a very old image of yours in your repository, okay, or you have a criminal for which you have a very old image. Okay. Yep. The idea is to not give a better visibility to the deep learning model, but to the human being who is basically seeing the image itself, right? It depends on the model. So, but the face detection models are, like, I think it's well developed. I think so it can detect it. Yeah. We're we're using L2 distance between the embedding. Uh,
So it's basically if you pass an image, get a vector, which actually
yeah, correct. Yeah.
so so it's not about accuracy, it's about how close the image is with the
Yeah.
uh, basically if the value is lower, the distance is lower, it means that the image is matching a lot more with the test image.
So
The
we
test image is matching a lot more closely. The test image is matching a lot more closer to the repository
Yeah.
image, and we are arranging
So
based on.
we don't have a quantitative metric as of now, so it's like a qualitative
It's
metric.
just a sorted list of distances, basically. Yeah.
Yeah.
Yes, exactly. Hmm.
So
Okay.
yeah. There's a distance there, right?
That's a distance metric.
Yeah.
Yeah.
So that will be. Okay.
Uh, yes, right. We get your point. Accuracy is something that we are very used to these days. So, Euclidean distance is quite old, but face detection models are pretty old. They've been around for more than 20 years. So, this is something that's very sound and it's being used in everyone's Google Photos app. So, if you upload a photo of yourself, it'll identify you. It's through the same logic. So, distance is something for face detection, face patching alone. Distance is a better option. The accuracy metric is actually distance values. So that for this particular problem statement. So we were very happy with the way that we worked together with our other two members who are remotely operating.
So we are total four
Four
members.
members.
Like most two algorithms are based on GANs, and then the pipeline and the use case and the UI, everything, the user interface. So now, if I can just send you this, yeah, like the face detection part.
Yeah, the 6 features that we showed initially, sir. That's the pipeline.
Yeah,
That's
then
our
the improvement part.
contribution. We identify that the order in which they can also be shuffled. So if you have an older image compared with a younger image. Sir, the model is alone taken. The weights are alone taken. The code's written by us.
Yeah. The Unity, the
Yeah.
whole UI is written by
Because
by us.
the image data sets are abundant. They've been there. Yeah. So there's no. We're just using the weights. The codes are written by us. Weights, the model weights. Yeah.
Those are pre-trained models
Pre-trained
which
models.
are already available.
For example,
Yeah.
we use YOLO, right? So YOLO is a pre-trained.
No. So it's available, but how you connect everything and put it in a single thing, right? So you have to write the logic for it, for connecting everything. Okay, individually everything is available, but you have to connect it, right?
Like we're using our name to get the repository, the folder from Google, and then we're using our image embeddings to compare the top 10 hits or a list of hits. It can be anything. We're just going to download the image, compare it, we'll delete it. So
So
that's our idea.
it's
It's about building the pipeline and our application. So we can give this to the police, and they'll be able to compare any images with their repository, so that they'll get the matches. Basically.
What is the novelty? What is the novelty of pipeline by showing images? Which is
6 steps.
actually confusing the user.
No, it's sorted, right? It's sorted
yes,
by
sir.
most similar images to the less similar images, right?
Yes,
It's
sir,
not. It's not a random image. That is the first image.
That's the first one.
Hundreds of lost matches which should be there.
Yes.
We are not for that.
Exactly, sir. The point which we the why we added 6 was, let's say we have duplicates in the repository. Let's say we have 20 duplicates. So these are features that, let's say the police have captured different, let's say, facial features of the person, different, let's say he's masked himself or something, and they're labeled it as him. So what we can do is if we list more number of data, it'll be easier for them to identify different features of the same person. So that's the kind of listings, because we don't have an accuracy parameter. The distance is probably it'll return us a lot more images. It will be helpful for them. That's the point, sir.
So instead of looking onto like thousands of images, you're just looking into 6 images.
Yeah, exactly. Instead of
So that's-
searching a folder full of thousands of images, we are making the sort easier for them to search, basically. Yeah, exactly.
might
Yeah,
happen.
it might be there in the data set, and it might have a good score. So if we have more images in our data set for the same person, it might be really helpful. showing even more, let's say even showing the top 20 hits might be helpful for them. So, yeah. So they can publish it directly to press or someone stating that these are the 20 hits that we got. You can compare. If you find someone looking similar to that, please report us. Something that that's why we have given 6 more. We can increase that number to as many as we want.
So it taught this solution like end-to-end solution, not just solving just one part of it. So that's why from uploading the
whole
images
pipeline,
itself to till the source of similarity, improving the images,
We
everything
can
we have
just give this
taught it.
TXT and the code tomorrow to someone, and if they have the repository, they want to search someone in the repository, it will be helpful for them. They can just use the application. We can give it to them.
You just need a Windows machine. That's
Yeah,
it.
that's it.
You have to click the exe, it will pop up.
Yeah, that's it. Just have to find the path of the repository. Just have to give the path of the repository, path of the testament, and you will be able to.
Thank you.
Thank you.
Thank you.
Thank you very much.
Thank you.
I can request others to please be quiet, and those who are presenting, please stick to the time because we are getting too late.
Thank
Thank you.
Yeah. Sorry about this, sir. The port was not working, so that's why we were. Sorry about that. Sorry about that to the participants.
Thank you, Team Shadow Lovers. With this, we move on to the last team of AI face detection, the Code Wizards from Hubli. Team Code Wizards.
Hello. Hello. Good afternoon, jury members and everyone present here. We are the Code Wizards from Kelly Technological University. Now we are working on AI face detection model. So this is the GUI of our working model. Simply directly detecting the missing person with the open face using the machine learning algorithm is quite easy. So what we thought of is by facing or covering some part of the face of the mask, because when the thief or the some other person, when he enters the ATM and all, the full face may not be visible. So I like to show the demo. Login. And here we are doing the one lost person is detection using web scraping technique, where the photo is given as the input. So we have taken a image of a Shah Rukh Khan like that to detect the face him. So it takes some time to process the things, and the output may be displayed. Processing. The outputs are displayed as shown here, sir. Now we'll show the same demo when the some part of the face is covered with a mask example, or the full face may not be visible, because when the full face is visible, it's quite easy to display the output. So still face detection. This is the face of the Shah Rukh Khan, whose the face is covered up and down. So we can see that by training the model, the output is displayed where the full image of the person is depicted, and some part of the other images you can see that the Virat Kohli is also depicted. But the majority of the image, what we did, the shown is the Shah Rukh Khan. By this we can infer that the person, even if the face is covered, the output can be displayed. And this was quite easy task. But when the task come to video pre-processing, because in CCTV footages we have a video, it doesn't have images. So what we have done is we convert the video into frames, certain set of frames where the video is converted into images, and those images are given to a model, and those model are compared with the input images. So suppose a person is lost, or the we have suspect roaming around, so we can cover the CCTV footage of the area, some bounded area, and cover them and give it to a model, so that the output is depicted. It's quite a lengthy task to sit a person and watch the video. So we have come up with a video task also, sir, using CCTV footage where the video is converted into frames. We had a short video of a person walking. Show that video. SRK image. Back. This was the video, sir. This will be playing. And the architecture which we are using is a FaceNet architecture, which is a trend on VGG architecture. So here we use the transfer learning technique, where the pre-trained weights are taken and the first layer and last layer of the model are changed according to the input. So the main task what we are focusing on the video, because the video task was not available easily. So we decided to convert it to frames. So this video will be converted into set of images, where we can convert it to 100 images, 120 images based on the video. We have taken a low resolution image because the CCTV footage or what we see is certainly have low resolution images. And the architecture of the image what we are seeing, they had mentioned that it has the 97% accuracy. But when we trained it on a low resolution image, we got around somewhat around 88%, which was viable, which was good. And because when we train model on various architecture like ResNet, VGG, and other architectures, so it was the less the accuracy what we got. So this was the research going on. This was the ML is a trial error method, sir. Because the architecture we keep on changing, and the output which we get the best we viable on that, sir. So that is the I will show that, sir. They said time of so. Quite nervous. It's okay. Same team, same team. हाँ हाँ नहीं नो सर इट्स ओके सर नो सर बाद में पी लेंगे सर This is our first hackathon, sir, so we had a good experience, sir. Yes. In Python or in machine learning technique, there is a inbuilt module, sir. When we give a set of frames, we suppose the video is about 100 seconds like that. The frame, a single second can be 164 pixels like that. This is the we saw the original video, sir. So this is the frames where the image is divided into set of images. This is the pre-processing part. That the original video was that in pre-processing we convert that image into photos. These photos are sent to a machine learning model and image.
So video capture module is there, sir, in which we can break down into images, sir, open source.
We can't directly process the video, sir. So by using this, we get the more accuracy, sir. So when that image frames was given into model, this was the output what the person was detected, sir. So further, we want to extend this work, sir, where the person is wearing mask in video, where we get more viable. But that part, as the time was constrained, we were only able to do this, sir. We ensure that we'll do that also, sir. When a person is wearing mask and roaming around the video using web scraping technique and also. Now the data set what we saw was came from the web scraping techniques. Sir. Yes, sir. Yes. Yes, sir. Instead of directly taking the video, we converted into images and sir. The images. Yes, sir. Yes. If we increase the frame, the images may increase, sir, and the data set may release. The data set may be very large, sir. So we should handle that data set. So we set a standard frame size where the data set is handled accordingly and compared, so that the processing time is also least. Because so that only, so what I said, we used something around frames. We used trial and method, so we got a 64 frame per second, which was good and viable. Where we got the accuracy, where the in 1 second 64 images will be generated. Downsample the video, sir, and low resolution because the CCTV. This was the high resolution video, sir. So we low resolution. We decrease the resolution of the video. Yes, sir. Yes, sir. The accuracy was more good in that, sir. But what we were thinking, because to use user and real world problems, we should solve a real world issue, sir. In high resolution, everyone can do it. So that was the main cause of our doing, sir. Video was the main focus, sir. Now we want to extend this work where the person is wearing a mask in a video, so that we can detect him effectively, and using web scrap technique. Then we get the Aadhaar card database, and also then we can compare directly with the Aadhaar card database. In Aadhaar card database, we have a retina scan, and also from that data set we can compare it, and we can get the details of a person easily, sir. Yes. Yes, sir. Yes. Okay, okay, sir. Okay. Face detection. Yes. Yes, sir. Yes. Eyes as the input. Yes. 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 Sir. Yes. Yes. Okay, sir. Okay. Okay. No, sir. What we were thinking, because yes, sir. Yes, sir. Code surely will show that, sir. The code. That only, sir. We use the weights of the model, but the layer changing and transfer learning techniques, sir. And we trained on various architecture initially, sir. That was the contribution. Without getting trial and error method, we cannot come to the conclusion, sir. Basically, using those trial error method, and we have done the conclusion parts. So I will show the code parts. Good. Show the ML part of the code. Has been our mentor. Yes, yes. Yes.
This is the code which you asked, like how the video clip is divided into frames by using the video file clip library. It won't take much time, so I will show you, sir.
In this laptop, the code is fully integrated. Well, we completely architect on what it is. So the switching is taken. So in this constraint times, we were more viable. Yes, sir, we can do it. That can be also
About Android app.
Android of
Take a mic, take a mic.
Hello. Android of we were not thinking, sir. We were basically. Sir, we can. This can be done. This can be done using Android apps, sir. Yes. Sir. No, sir. We were capturing through website only, sir. We were Android web was done by other team. No, sir. Mobile using no, sir. We were doing in laptop only, sir. From initially, sir. It was the other team, sir. The team number 34 somewhere. They were doing on the Android. They were just beside our table. Yes. Thank you, sir. Thank you, sir. Thank you. Sir. Yes, sir. We'll show it. Sir. It's generating, sir. Now the code is running and the output is generating, sir. So this is the code what we have written, sir. By this we give it to a model, as I said, sir. Everything again face recognition only, sir, but using with more advanced technology. Yes. It's available, sir. It's not new thing, sir. It's available, sir. But where we apply matters the most, sir. Even if it is available, sir, many of them may not be thinking of it, sir. Sir. I mean, of doing, sir. applied course, yes sir. Sir. Large data set we have not yet trained, sir. We are dealing with small data set due to constraint resources. So that we have done, sir. Thank you, sir. Thank you, sir. Thank you, everyone.
Thank you, Team Code Wizards. With this, we come to the end of AI face detection problem statement. And the next problem statement that we are moving to is bank account analysis. And the first team for bank account analysis is Finara Trans Audit from Finara Technologies Private Limited, Chennai. It's a request from everyone to please maintain the decorum of the hall. Please be silent and listen to the teams that are presenting.
Firstly, thank you for this wonderful opportunity provided by Government of Karnataka. And myself, Shobna, I am from Chennai. We are into Finara Technologies Private Limited, based in Chennai, as I told you. We are purely into fintech solution. So you can see here our problem statement, what we are solving is like bank account analysis. And we was awarded as best 5G use case by Department of Telecommunication also. So you can see next. Okay. Now, talking about this bank account analysis, we are just creating a kind of unique kind of solution that is common, secure transaction platform. This will act as a one-stop solution for all kind of transaction platform, I would say. Let's consider the transaction type: ATM, UPI, interbank. So right now in this task, we are just focusing only these kind of transaction types. Whereas where we can determine the crime analyzation. But talking about the cross-border remittance or as like money exchange, where we'll be finding the high risk range over there in terms of financial crimes. And also, you can see here, we can have the source like statement, not only statement, but also we can also have a kind of business switch where we can get or gather the unique statements to find out the suspicious transaction. So now you can see here, we can get the data from NPCI switch, bank internal switch, and also money exchange switch. So what we are doing is we are just capturing all the data as a comprehensive, and we are just sending that to our kind of common service platform. It's a kind of common secure transaction platform. What we are doing here is like, we are just doing a kind of complete risk-based assessment. So what it contains is because we do have nearly 16 parameter matrix, especially for the compliance. So not only that, we are also using a unique technology where we can determine what type of risk can be occur in the, in terms of STPR. And most important, like we are also integrating the OFAC checklist and World Global Sanction List also, along with SPR check, watch list, blacklist of customer. So all data based on APIs can be integrated in this one-stop solution. So whenever you get any compliance, talking about the police side, whenever you're getting any complaints in terms of any fraudulent activities detector or any suspicious activities happen, you can use this one tool where you can do all kind of activities to extract the particular suspicious transaction details. And similarly, we also having a risk score list. I'll tell you, this is the concept that we are having here. One is like we are using a kind of different risk matrix here. It is purely a kind of 100% dynamic compliance, and we are also focusing the global compliance also. Here you can see the first one is risk level, and the second one is customer type. So let's consider if someone is doing any transaction from the country Lebanon. So as we are aware, Lebanon is the high risk country. Or if you're talking about the South Africa, so for each nationalities or the countries will be having a risk score. And similarly, whenever the person is doing any kind of transaction from the origin where the risk area is occur, then that, we are also calculating that uh, particular country as a risk. So this kind of parameters we are having. And also we can see like PEP list, nationality, customer type. So this kind of transaction also can be detected in one spot. So we also have a demo. We'll be showing that now. So here what we are doing is, We're just getting a real-time transaction provided by police. So what we are going to do is we are just going to log in as end user of police. We are going to log in here. So you'll be getting a dashboard. Okay. So in this dashboard, like what we have designed it is to have an effective decision making tool. So what we are doing is whenever you are having any kind of issues in terms of handling the bank statements or any kind of transaction platforms, what you can do is you can just capture that particular data in any format, irrespective of any format, irrespective of any banks. We have designed the system in such a way which adopts the compliance also. So what will happen is, go ahead. Okay. So now you can see here in real time what we have done is we have integrated 165 banks and also the branch of 1,48,000 branches details are there. So here we are just categorizing the branch details using the statements which we are having. Go ahead. Okay. The uniqueness of the solution is, let's say, I'm the person from Lebanon, I would say. So I'm doing any kind of transaction as an origin country. So I'll be adding a high risk code there. And similarly, I'll be transmitting the money to him. So what will happen is these two accounts get linked. And what he will do is he don't want to copy to the corruption or any kind of fraudulent activities. So what he will do, he will split the money. He split the money to send it as amount like 10,000 to him, 5,000 to him, and kind of 1 lakh to him like that. So that people won't get any kind of compliance activities related things there. So what happened is we have to check again the all amount of money compressed as, and the particular person will be getting that money back again. So in that manner, we have to analyze the statement. So now here you can see, I'm talking about the police user list here. Okay, so this is a kind of dashboard, I would say, where you can feed the details of the sub user. And here is the uniqueness where you can also give an authorization to whom, where you can give the access to the particular police. Yes, sir. Yeah. Hmm. Okay, sir. Yes. Yes.
How can you give me one statement, one
Hmm.
where calling out details from all those different formats?
All right, sir. So now this is the dashboard we have designed it especially for the police. So in a short duration, we have designed it this. So you can see, go ahead and selecting the bank, what type of bank it is, and you have to import the file. So right now we are available with only one format. So sorry, one file at a time. So you can also do a multiple file uploading process. So I'm just going to show you a real-time risk analysis using this. Yeah, sir also gave task. No.
Sir, what we are doing, sir, in the 138 banks, we are splitting the banks into 18. Yeah. They are taking about 138 banks, 1,60,000 branches. These are all openly available data that they are talking about. I'm not interested in that. Sir, what has happened? There are these different formats of different banks which have been provided to them. visualizing it, you show me 10 different banks or 4 different banks formats and then give a single format output. That's all. You don't have to do anything. You don't have to explain anything.
Okay, sir. We already initiate the one bank transaction, one format. We already, you can see that here. It is completed. It's completed. It's completed. This is now we are showing. Okay, again we can again do that. Yes, yes. Do it again. Do it again. Madam. This is SBI, sir. State Bank of India. Yes.
Private, other private banks.
Where, sir,
National bank formats are similar. Little bit different. So you take Canara Bank,
sir,
whatever bank.
sir, this laptop doesn't have those facility because we are developing in another laptop. So the laptop doesn't have a wire facility. Yeah. Yeah, we already show it to all the people, sir, who are visited. Okay. Yes, sir. Yes, sir. No, for the time being, in this laptop,
One suspicious transaction in real time using the database.
No question of suspicious transaction. For investigation. But our problem statement was slightly different. So have you done that or not? I'm trying to understand.
sir, we did four. Yes, sir. Please tell, sir. Yes, yes, sir. Sir, sir, multiple bank statements we already integrated, sir. 18 different bank statements we integrated. All these 18 bank statements we got it from RBI directly, and all the data that we feed it here also we get it from their banks. Sir, here we will bring it the laptop here itself, sir. Sir, that laptop doesn't have these, this.
ये पावर सॉकेट यूज दैट वन डेमो जो बनाया वो दिखाऊंगा ये सब मार्केटिंग से नहीं होगा
Give the laptop.
लेके आओ ना वो थोड़ा आपका प्रेजेंटेशन हो रहा है आप अपने आप को ऐसे प्रेजेंट थोड़ी ना घोषित करते हो continue she will get that what happened why you nervous go up the show go what nervous duplicate I will do it wait क्लिक होगा तो छूटेगा क्लिक कर दो हट जाएगा निकाल के वापस डाल दो कई बार प्रॉब्लम होता है ये नहीं चाहिए दिस इज मैक थोड़ी ना डायरेक्टली हो गया लगा दीजिए This port has a problem. Done.
Don't take this mic, start. Take this mic, start. Don't touch me. Start. Multiple files analysis. பிடிஎஃப் போட்டுருங்க போட்டு அந்த ஒரு ஃபைலை மட்டும் காட்டிட்டு முடிச்சிடுங்க ஓகே சரியா பிடிஎஃப் ஃபைலை போட்டுருங்க பரவாயில்ல அது ஒரு பக்கத்தில் வந்துக்கு ஆனால் நிற்காது இல்லை Okay, now we are uploading multiple datas. Then UPI. UPI. Yes. Wait. Import it. Okay. Go to the next. Refresh it. Refresh it. Text delimiter.
If they have not done it here, there might be a company who has some solution. We are not interested. This is not a marketing platform. So they can't market their product here.
Okay, sir.
What
Thank
they
you,
have
sir.
developed here, that is what we are interested in.
Sir,
We are not interested in your product.
What you develop
What
Sir,
you have done here,
sir,
that is what you
can you show that, you have lots of technical people. These people can analyze what we did for the past 24 hours. So how can you say, sir, we are doing, we are,
Sir, we'll show you what we did, sir. We'll show you what we did so far. Okay, because that is our hard work. We are not playing anything with that. Sir. So actually, we built this solution from yesterday onwards. You can see here. Okay, so these are the database that we have created for each tables, and based on the parameters also we have a risk score has been decided here. We'll show you that table also with you. The backend process that we have done. So we have taken one statement here. So here is the risk matrix analysis that we are doing here. Okay, now we are showing the detailed credit account from the statements that we have. In one single statement, the beneficiary is here. Sir, 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 actually, sir, that's what we was doing, and we got a call. We came here, sir. Still, we are trying also. So you can see here, sir. According to the sir's guidelines, he asked me to do one task, so we are trying to do that. Okay, thank you so much.
The next team. Yeah, the team AML squad, please.
Image. Hi everyone, respected jury. We'll directly get to the problem solving. In our system, we basically have three different modules. We have divided our system into two different modules. One is case management, and another is investigation decision support system. The case management is basically there to basically add a specific case and then add multiple point of interest which you want to add along with their bank statements. Once that case is created, then we have a bank statement parser available, which basically would parse and get put the data inside a central DB so that our investigation decision support system can utilize it. There is something a compute layer which basically tries to do some visualizations and try to extract some insights so that when you look at the investigation research system, it tries to help you in terms of getting some information of the bank statement which you have just parsed. Along with that, we have written a mapper inside our compute which basically tries to standardize the headers of different bank statements so that when the investigation support system shouldn't have to worry about that. With that, I'll directly move to the case management. In case management, we'll start with the case creation. So let's say we are starting with the case creation. Let's say we are trying to solve for a one FIR. So if you go to case creation, yeah, these are existing cases and POIs which were during evaluation stage 1 and 2 we had created and showed to the other mentors. We go to case creation. So let's say we create a new FIR ID 1675. Let's name it CD1 or something sample. So with this, a case is created. Now let's go to the POI. So when you go to a POI, now with older cases, you'll also see the newer one, which we just created, which is 1679. Now let's add a POI ID. And here we'll be uploading the bank statements and showing you how we are passing it along with our backend. So let's say put A, sample user, PAN card, you can put you just put it dash for the PAN card and Aadhaar card. The reason we put this PAN card Aadhaar card is just because the bank statements generally have that kind of an information. Sure. Just upload one of the PDF files. See, PDF file. So when you are submitting this POI data, this is basically parsing your PDF. So we can show you the backend. So let's say if you click on our Karnataka Police bank account, just to show the back. So this is a Swagger API. This is currently hosted on Azure. This basically would parse your data. There are two pipelines which we have created. One is a custom pipeline which we wrote. The second pipeline is something which is an Azure form service which is available. The reason why we did two is because we felt that for image kind of PDFs, Azure was working better. For the like a PDFs which were more of textual nature, which doesn't have image-based PDFs, which are not image, where you can do a copy paste. Our solution was running better, and obviously it's cost effective because we don't have to pay to Azure. So with that in mind, so if you go to our listing directory, just to show you the reference, or you can just go for the PDF. Yeah, so this is the PDF which we just uploaded. This is like starting from 1st October 2022 and goes. Yeah. Okay, then maybe we'll directly move to the dash. Dash. Yeah, we just wanted to give clarity considering previous hacks. So, no, in clarity in sense of our backend. Yeah, okay, no worries. This is the investigation case system. Considering that we created a case, we uploaded a CSV, we had a POI. What happened? Sorry for the delay. Just give us 10 seconds. This is loading. We should be able to populate the case ID and user ID and show you the detailed analysis. Yeah, yeah, and our dashboard has loaded. So basically, this is the ID which we created and the user which we created. So once you do that, what will happen is we'll have a sample ID, and it's basically currently parsing. It should show the initial transaction and the latest transaction soon, or we can show an existing user maybe. Just what happened? Uh, just yeah. Okay, finally, I'm really sorry, but yeah, this is what is when it actually runs. It will take time, and currently we were using on restricted your services. So this was one of the PDF which we just uploaded. We saw that this PDF basically these transactions had equal number of debit and credit. But the interesting part to know is that all debits happen to IMPS, whereas the payment instruments which are used to credit were all different other payment instruments. Which we can maybe look deeper in the volume and frequent analysis. So when you go into volume and frequent analysis, we try to understand why do we see such a debit and credit ratio, and also why such specific payment transactions. Yeah. So the we see that there is a suspicion. So basically, there are 4 transactions in 1 month of scenario which has happened. The suspicious part is basically that on a single day, the number of volume which money which came in and went out are exactly similar, which basically means that this was used to move money in and out. Uh, and if you scroll down, if you go to frequency of transaction, this is where you come to know that even though the credit, so if you see the credit number of frequencies or more, which means when money was credited in, it was again basically sent in smaller amounts and for multiple frequency. Whereas wherever they were pulled out, it was basically pulled out in larger amounts in less frequency. The main aim of this dashboard is to provide a precision support system that once you upload such transactions, a person or an agent who's doing a forensic report knows which areas of domain in the timeline he should focus more on, he needs to look where. With that in mind, we'll go to pattern analysis. One more thing which we wanted to basically do was we know certain patterns which we are aware of, such as high volume credit transaction, high volume debit transactions, which we might want to see. Similar to that, so right now what you see is basically the PDF which was passed and the transactions which are available here. What we have added is we have added filters such as high volume debit, high volume credit, this weekend or holiday, basically to give us different patterns which you might want to see the transactions in and maybe export them out. Now, the reason why we're showing this is because when we work with the on-ground agents, we can be made aware of more patterns which you might want to add here, which can be added as filters for the past statements, and you can export them accordingly. Uh, there was one more thing which we tried doing, which was network analysis, transaction network analysis, where we tried to take one user and try to see if we can basically try to plot the top 10 frequent beneficiaries in a graph format. Uh, Basically creating a case management system so that multiple uh,
can be merged irrespective of what format they are given, digital format, that is whether they are PDF, Word, Excel or what, number one. Second, whatever may be the number of fields that they have, that what is the challenge in that? The challenge is that your debit account will
Correct.
So they have to be properly merged in a common format. What have you done about that? Please show that.
Sure. Sure. So, which is basically format management, right? So when you are uploading in the previous dashboard, where we showed you upload of the POI, where we showed you one upload for one user, that same model, the same pipeline, basically currently processes one PDF, right? We can basically give you a feature of multi-upload, where you can upload multiple bank statements for one user, but our backend would remain the same. It just has to process every PDF in one by one and has to concat them. Yeah, multiple, no, multiple. Yeah, so दिखाओ. So number one, we wanted to clarify, right? Yes. So right now, when you see the database, it has. Yeah, we have done it. We can upload multiple. Yeah, if you want, we can upload another PDF of different format, show you, and then again show you the output. Okay, so that was something we first wanted to build the first foundation. So we haven't done the linking of accounts, network analysis of, but considering that we have built a system which puts out data which is readable, and we can draw visualizations out of it, network analysis of that is possible now, is what we can definitely say. We have already standardized, so you can open these files, sure, we can open these multiple files, sure. Definitely. We can show that, yes, we have done it, so we multiple files. Sure. So we already looked at one PDF which we uploaded. So if so this was the user, if you remember the name, current and all. So in fact, we can open them and show you they are of different format, and we can even show you the sure. Uh, so I would say we won't want to solve it that we would want it to come individually from different banks and then join it on beneficiary from to and fro. Sure. Just open the Excel. No, we have done it, sir. It's just a stressful situation. That's it. Nothing else. Which this is what bank is this? This is 02, right? This is Union Bank. Show the PDF, the initial which we showed. These are debits and credits, sir. So this would be the balance. This is an output. This is an input. This is an output. So multiple inputs or other outputs. Outputs are standardized. Yes. Okay, understood.
So this is one output.
So one we already showed you, the one which we downloaded. We'll upload a new one now.
We'll directly show this.
No, I guess everybody would want to see it dynamically, I believe, right? No, just go to the case management system and upload a new CSV. Upload a new PDF. Upload a new PDF. Yeah, of a different bank. Left side, pin, right? Huh. Yeah, sure, sure. So right now, the intermediate outputs which you saw would still have different fields, but we'll show you the code. So when you saw it in the dash, when you saw the visualization, that has code to standardize it, and I'll show you the code. Yeah. We have done it for 7 8 months. Yes. Upload a different bank. The PDF which you upload, show that PDF to everyone. Take ICICI maybe, or United Vijay Bank, anything. So if you see, this was the case. What was the case ID? You remember? Okay, just go to the directory, see, refresh and see. So yeah, so you see the new output has come. This is for a different bank now. This is for a different bank now. Now I'll show you the part of conversion also. Just open GitHub. Now I'll show because pick a bank which has a different one. Pick. Sir, the numbers. So input was also different. Show a different PDF which has a different headers itself. Like just show that PDF first, then we'll upload it. Yes. Yeah, but our foundation of standardizing inputs. Right. Sure. Show the ICC. Yeah. Yeah. So headers would be different, but I'll show you the yeah. This is some other bank which was given to us as part of the sample statement. So the so this is the associated CSV. Now show the other ICICI one. हाँ, तूने yeah. This is first bank. This is ICICI.
Okay, we got it. So yeah, thank you. Thank you.
I'm more than happy to after you finished. I am more than happy to show you differences of everything. Yeah, that we can show you 100% guaranteed today itself with no more coding required.
Thank you, Team AML Squad. The next team is Team Elysian from Nagpur. Team Elysian, please.
Hello. It's a direct output. Yes, ma'am. Yes, ma'am. Yes, ma'am. Sure, ma'am.
Yes. So let's get directly to the prototype. One second, sir. So this is what the data that was given to us. These are all different headers. So like this one has HDFC, the data it's written debit here, then it's written credit here, there's withdrawals. The headers are all different. These are all different bank accounts. So what we have done here is, yes, sir, yeah, in my hack to skill. So sir, what we have done is like we have merged it all into, okay, sir. Yeah. Yes, sir. Okay, sir. So this is a website we have already deployed into the Azure. So after combining all the different headers of the bank accounts, this is what. So this is what the output we have got. So like the first like a bank account that was sheet one. So I've just taken it as hack to skill. So we have multiple banks. So this is Act to Skill, this is the SDFC, this is the ICICI, and they are all under a uniform header. They are all consistent, and we can also directly search for it. So like if I want to search for a particular UPI, so let's take this one for example. I search for this, and all the transaction regarding this UPI will appear. Yes, sir. Yes, sir. Yes, sir. Almost all of them have changes. So this is the first one. This have withdrawals and deposit, like different columns. Now the HDFC one, this one has debit and credit. Now this one has withdrawal amount and deposit amount. This is a CR and DR. Now we have to all now combine it entirely into one. Deposit, withdraw, balance, date, and account. All combined, all we can search it entirely without. We can also search by date, the account type, the amount of deposit, and like the description. So actually, so this one has sheet one. So I have made them a bank. That was not available. So the problem you can see directly here. The like bank account analysis. The problem is directly we have see we can see here these are all different headers. We can't make a uniform database if they are all headers. Like you said like the withdrawal is fourth column, then eighth column, 10th column, 11th column. We can't normally process it. Now another problem is that these are not available in CSV. So what we have done this is also made them available in PDF. So if I take a random PDF, I can upload it. Now the one of the problem is again with the PDF is that so this is a PDF I've taken. We can see that this is not needed. The branch, account number, name, address, balance. So this disturbs the entire consistency. So what we can do is zoom into the process we want, the data we want. We can extract this data. So it's from this year to this year. If we see the output of this, so if we use this method, you can see that this if we directly read one, this will cause an error. If we read this one, this is absolutely consistent. Transaction number, check number, debit, credit balance, it's all consistent altogether. Now another feature we have added is like the database analysis. Now we had five statement headers. We have combined all into one. Now we can analyze this, which one number had a higher number of statements, which had high balance, deposit, and which transaction was using, like the IMPS, cash, UPI, NEFT, RTGS. We have analysis of that. Yes, sir. One second. So this is all. This is the FGFC, the ICICI, the United Services, and these all the data sets are provided by the Hack to Skill. So nothing. So that's actually expanded. It go away. All different bank accounts. We did by extracting the OCR. Yes, sir. Entirely to my view because the data set was just given like 2-3 days earlier. So we just yes, sir. One second. Yes, sir. Yes, sir. Yes, sir.
Yeah, sure.
So actually, right now it's showing some error in reading. So actually, there's just some error in reading the input file, but like the code is entirely there.
Thank you.
Yes, so actually, more features. If you could show. Yes, sir. So this is the only for the bank account analysis. What we have added here is also for like now we know that electronic e-statement is also there, but like if we have physical there, like physical, a lot of bank statements are there. We can analyze them. We can take the data from there, get the coordinates. Now let's say like I want to just yes, sorry, sir. Yes, or no? Like if I want to analyze a statement, let's say I want to just scan this part. I can take the picture from a mobile or anywhere. I can get the crop canvas. I can download there. Now when I extracted all the text from that OCR is all, and I have it here. Now what we have also added feature is like we can see all the transaction, all the account numbers in there. Like if I input a random account number here and submit it, the value will be false. The value will be false. But the image we have here is this. The account number we can see is 1234. If we input this here and we submit this, one second. This. Yes, so just only offer transaction amount. Now the main feature, like the main we have done is like for the detection of fraud. Now we know that in a bank statement we have a credit, debit, and balance. So for that we have used like anomaly detection, the unsupervised anomaly detection. Now for this we have used a very large impact data set which contains around 80 to 90% real transaction and and other fraud transactions. We have analyzed this and built a model through it to detect like the book of like fraud statements. Thank you, sir. Thank you, sir.
Thank you, Team Elysian. With this, we end the problem statement bank account analysis. Requesting the jury panel to kindly score the teams. Moving on next to the next problem statement, we have the first team for crowdsourcing of records, Team Kubertekis from Graphene AI of Bangalore. Team, please try to stick to your timings as soon as possible.
So, hello everyone. We are Team Kubertekis, and our product is Namma Sherlock. So, it's the spy that you need to crowdsource all the data from the internet. So, let's just quickly move on to the demo. Uh, when we're trying to crowdsource data, we're considering all unique parameters. So, first one being the name. Now, name can be a bit vague, so we can add any context to it. Say, in my name, I can append engineer. That will give a more refined search. The other one can be phone number, and the last one can be your Twitter handle. So, let's just try and search for a person who's actually in the room to get to know if we are actually getting the data. So, we will search. Uh, yeah, anybody who wants to volunteer, we can do. Sure, sure. 9900 979900. Okay. So uh, our Sherlock is searching and crowdsourcing for all the data that we have available on the internet. So let's see what we get. Okay. Yeah. So I think we got the data. So we'll move from left hand side. So you can see we got a set of related images. So these are all the related images to the profile. This need not be the profile image, but all the related images that may be associated with any individual. Then we got the name and the gender and also the location. Now, below all the things that you see in these badges are all the related information to that person. So, if you see, there are certain law cases that are tagged to this person. So, some overlap of the data that might have happened. You can also see locations like Chikmagaluru and all the things that we could map to that person. Yeah. Yeah, so the point being, here we're trying to map different sources, right? We only got the phone number, we did not get any information. The next, we tried to search for the name of the person, and then we tried to map multiple sources. If this could be any search on any law related website, news related website, media related website, and we found the tags. So if you could go up, you could also see all the related areas that person might be associated with. Now, this ID seems to be very active on Twitter, so we got all the related persons that this individual might be associated with. So that also gives us the touch point to all the people that we can connect to. Uh,
So we are trying to extract some of the entities that are present in some of the tweets and the bios that are related to search profile. So in there, some of the common entities that might have come.
yeah. So no, so actually, this is not the header. So this part you see is the area that is reserved for Twitter. This is all the entities. It's not related to any social media website. It's just a common global search that we did with that person and all the related repetitive information that we got from the data. So that's not related to any social media map. So, so I don't think there's a link attached to it. We did a global search, so it's a tagged information. So if you see here, where
No, so yes, sir. So okay. So to combat that, so as you mentioned earlier, so whenever we search through even Google or Twitter, like we find a lot of data sources. So for that, we've also tried to come up with a logic wherein we take in three parameters into account. One is the page ranking already given by Google. So when we try to search a person's page with relevant keywords, it tries to rank it accordingly. And the second one is we also have some other entities that we extract from this. We try to see if the syntax is similar in the search results that we are getting, probably a Twitter. And further, we are also trying to see if it is semantically similar. So based on this, we are giving some confidence scores. I think.
अभी डेटा चला जाएगा भाई, मत कर अभी.
So the novelty is disambiguate the person's profile from different junk profiles that we're gonna get. We're gonna get a lot of profiles. So give you a confidence matrix. We're gonna say this is relevant to the person's profile.
So yes, we're actually coming to it. So let us like complete the entire demo, and then we'll be. No, but yeah, like we didn't get an opportunity to present the entire stuff, so we had the confidence score up and coming. So yeah, absolutely, like we'll do it. So there is some issue with the projector.
Is it doing something on my system? Because it started to hang all of a sudden.
Restore. Okay, sir, can you please provide your mobile number again? So can you please provide your mobile number again? Yeah, so like let's do it on the same one, and like we'll go through some other one as well. Scroll करता है. Yeah. So like let me complete all of it step by step, and we'll come to as to how do we get that tags, and like yes, some data might be junk, and how the rest of the data is helpful. Yeah, let's wait for it to load, and then I'll maybe explain. Yeah. So as Tanisha already started with the tags that she explained, so we had certain tags that were coming up related to self. So if you can just scroll up a little bit. So yeah, if you see that Santosh Kumar, Santosh Babu IAS, in Johar versus Union Ministry of India of Law, by any chance, like, okay, so it might not be relevant, or okay. Okay, sure. Like, yeah. So let's do it for Tanisha. So like by the time it's loading, just for context, we collate data from a variety of sources. So that sources will be Google, Instagram, Facebook, Twitter, and we just don't collate those data sources. Once we, so yeah, before I go to it, once we get the data, we apply matching between those data that we get from various sources, and based on that, we rank those data that we get, and then we provide it to the dashboard. So in that way, the data that you're getting is being vetted by our algorithm. So coming on to this, so to give some background, Tanisha is a software engineer. So she works majorly on front end. So you can see that Tanisha Sabharwal, her profile picture is coming. So if you can scroll to some. Yes. So, sir, I'll come on to it as to like no information on the web can be 100% accurate. There will always be some ambiguities that will be associated whenever you do any Google search. At the end, the data on Google is generated by people like us. So if you see, it is her image that's being generated from wherever she has posted those images. So just to give some context, right? So these particular tags that we got. So Nimish is one of our friend who works extensively with us on various projects. Similarly, 100 days of code that she actively does. These are the recent people who have interacted with her on her tweets. So if Tanisha, please go to this specific one, and we'll see that like he might have tagged Tanisha in some recent tweets. So if you see like Tanisha and they are related, so this gives information to the police department that these two persons might be related, and it reduces the sample size to focus on a lot less individuals than a lot more. So let's go back to
it. So if you see her Twitter footprint, her direct Twitter link came in. So instead of you going around and searching for 10 people, we made the task easy for you by collating various information and giving you that confidence that it was just one person. Coming onto the Facebook footprints. So coming onto our Facebook footprints, so when we were analyzing it, so if you see here, it says 100%, so it's just one figure, right? If you see this, there are a lot of Facebook this, and we haven't given 100% for that. There is a similarity score that's associated. So if you see, it came up, and Tanisha has commented here. So it gives the police department some info. They can go back to this profile, write to Facebook, and get that particular data that they're looking for. Now let's go back to the yes. So, like you are getting so this is not something that you'll get directly, right? This takes some effort, and I'll explain into our algorithm as to how we did it. Yeah. So let's go back to the yeah. So these are like various profiles. We can open them, but in the interest of time, I'll go to the related links. So if you go down, these are some of the things that Tanisha like is very active on Script. So she puts a lot of documents out there on Script. Now, just to add on, so we'll be playing a demo. So a lot of times, the like policemen might want like easy access to some information. They just have the phone number and they want to get the data. Let's see how it works. And we can try with anyone's phone number in the room. Like we have not hard coded it. So like we'll do with someone's number in the room. So if you see, it gave like Tanisha Sibarwal Vodafone idea. So this carrier information is also helpful to the police department. Yes, it is available if you reach out to Vodafone. You'll get to know as to what is the carrier that she's using. But we have collated the data in one dashboard and provided you easy access with this WhatsApp bot. Coming on to Facebook, this is again related to her. LinkedIn, this is an exact LinkedIn account. Twitter, this is an exact Twitter account. And similarly, this is something that she did in 2017 batch. She was a topper of her class or something. Now, again, just to emphasize on the fact, it is not necessary that if some of you will give me your number, all of these links will come. You might not be on that platform. So we will get the data that is present on the internet. We are not generating the data. How is it different from? Okay, can you give some context like as to what does it do? Okay, so no, I have one question on that. Does it do comparison across various platforms and ranks it for you to make your job easier? Like it's just a question. I'm not aware of the platform. If it does, then yes, there will be some similarity between what we have developed and what the Cynic solution already offers. But if it doesn't, then this solution eases out the task for you. Like, that is our counter to that. Rest, like we have not hard coded it. Let's try with anyone's phone number, right? So I'll bring my phone to any of you and let's do it real time. Let's see if it works or not. And if it doesn't, we'll be happy to improve it. So like anyone who is interested, please raise your hand and let's do it. And adding on to that, like, so before I come and ask for anyone's phone number, we'll definitely do it. I'll just add on. So please come back to the architecture slide. So we have not developed the solution just from a hack perspective. We have developed it keeping the scale in mind. Tomorrow, so things just don't end out of the hack, right? If you're really implementing it, you will need it to be scalable. You need if 10,000 requests come per second, you need your system to respond. So we have developed a solution on leveraging Azure serverless. So as this particular use case requires a lot of tasks to happen in parallel, depending on the previous context, serverless is the perfect solution for that. Similarly, like this intelligent compute engine, again, like this is the brain of our solution that does the mapping between those data sources. And this is hosted on a normal VM, so there's nothing great with that. And again, with the interfaces, we have not just provided you a web-based, it's a mobile-based interface as well. Now let's please raise your hand and I'll come up to you. Let's do it. Please come on the stage. Let's do it. So so that we do it in real time, I'll ask his number in front of all of you. No, we have. I'll show it on this also. If you want, we can do it there also. But I think, okay, let's do it. So Tanisha will do it with his number so that it's, yeah, like you can do it. Please speak out your number to her.
So my number is 8072 998 695.
Till the time Sherlock is coming back, I'll again circle back to the point as to why were tags like Anupama coming. Yes, they are not 100% accurate. There might be ambiguities in that. But our entire purpose is to help you narrow down your searches and not be that perfect solution that offers you everything out of the box. I don't think we have achieved that, and we are not even claiming to do that. Now, coming into is this thing. Okay, so this was a number, and by any chance, okay, so is this your email by any chance? So it's his email that's confirmed right there. So if it is confirmed, that gives the police a concrete data point to search on next time. So they got a very important information like email. Now, by any chance, are you interested in? Right, I'll come on to it, sir. Like, please allow me some time to explain that. By any chance, like, are you interested in, say, swimming or various countries, or do you do that? No, okay, that's okay. I'll come on to as to how we exactly got it. So you are active on WhatsApp with this number. So that's again pretty clear. I'll come back to it, sir. I'll not leave that point. So let's just complete the entire flow. Please come down. Absolutely. Then I'll come on to it. So we have picked these. So maybe like he's on Facebook and liked certain posts related to that, and we have got those tags with respect to those posts. Yes, they might not be 100% accurate, but it'll ease out the job for the police department. So like that's an entire counter to it. We don't claim it to be 100% accurate to be. Yes.
Email ID or not.
Right.
If I have a person of interest who is wanted criminal, he will not be standing in front of me to confirm. No, it is my ID only. I am using.
So, but
That is my challenge. So that is where if I have in that dashboard, you have almost 20 different parameters.
Got it.
Out of which only one WhatsApp and one email ID who have the matching.
Right.
I have to go looking and waste my effort for 18 other parameters.
That is correct. Right, right. And that is a good suggestion. Maybe we can have a confidence score in those tags as well.
Otherwise, you're good. Thank you.
Thank you.
Thank you, Team Kuber Techies. The next team is Team Breakpoint from Bangalore. Team Breakpoint, please stick to your times.
Excuse me, sir.
आपको ये प्रेजेंट करना है या एक्सटेंड करना है? I'll do duplicate, right?
So, sure, sir. Yes. Good evening, one and all. This is Team Breakpoint. So, firstly, we are building a police investigation portal. So, it is called Trinetra. There is a reason why we call it Trinetra. So, if you see the emblem there are four ones. So, it is nothing but confidence, courage, power, and faith. That is what defines a policeman. So, we are indeed grateful to be here to work for them, to build something which will help them. So we believe that Trinetra will be that third eye where it will help the police person who will be in the field. So now let's see what exactly we have built. So this is our dashboard. So we have mainly focused on four areas which were given to us by our mentor. So the first thing which they asked us was the more data. Fetches as much as data as possible and the more accurate data, and it should be scalable, and the format how it will be given. So this is what we have focused on. And so if we see, as sir mentioned about Sainik, so Sainik, if we see, it just fetches the data from the surface web. Surface web, if we see, is just 4%. Just 4% of the entire web. But there is much more called as deep web and dark web together, which is 96%. So what we will be doing is we will be fetching the data from the surface web, dark web, and deep web. So we'll get as much as data as possible. So how we get more and more data? Fine. So now how do you say that the data which we get is accurate? So if we randomly map, as we see, there will get many tags. So we don't do that. So what we'll be doing is we will be classifying the more accurate ones and the false positive ones. So we'll demonstrate it as well. So now when you give the user input, username, it could be email and phone number. So this is it. This is how it will fetch the person's ID. Yes, sir. Sir, any mail ID or username. The more data we have, the more. Sure, sir. So now as we'll be fetching the data from surface web, deep web, and dark web, so it will take a lot of time. It will not lot of time, but 2 to 3 minutes minimum, so that it will fetch more and more data, so that we need accuracy, right, sir? So it will fetch date time. So by the time we will, we are fetching it from surface web, deep web, and dark web. So the entire web we are covering, so it will take little time, so that we will go through that. And now if we see, so so this is how once you give the input, this is my brother. So when I gave my brother's input, this is what the information which I got. So if you can see, he has multiple usernames. A person in Instagram, he'll have one username. In like in Twitter, he'll have another username. So we will be matching multiple usernames of one person. Even a criminal, he could have multiple usernames. So we will be matching all that with the help of a regular expression. And also we can see his description. And also we are fetching the social media accounts. We will be using 500 social media accounts. We will be searching, scrapping, and then we'll give the data. If you can see, these are all the social media accounts which he is part of. And if you click on it directly, it will take you to the person's email, like the person's link. So what is his link? So you can verify him as well. So not just this, we have multiple also. You can go to Medium or any other Snapchat, Medium, whatever it is. GitHub, whatever. So it validates that the data, we are not just giving any tag or just a name. So we are also validating with the perfect link. It will redirect you to the particular link as well. So also you can see, as I was talking about accuracy all the time, you can see that we have social media accounts and false positive accounts. So the tags which we generally see when we do global search, we get tags similar to that all that the content. So what we are doing is we are classifying it. We will make sure to say that these are the false positive accounts. Only those are the person's real time accounts. These are not. These are just the tags. So the police personnel can ignore this. Only that data is accurate. So we say that our data is accurate and we are fetching as much as data as possible. And also, when we fetch, so sir, if we do crowdsourcing, we'll be fetching lots and lots of data, whatever the infrastructure if we see. So we should make sure that whatever the model which we build, it should be scalable. For that, we are running it on a Microsoft services instance. In Microsoft service instance, what happens is they have three better provisions. There is something called as Microsoft Root Course. So if we generally take a normal Microsoft services or any other services, when we do the scraping and all, it will put hell lot of pressure on the CPUs. So what Microsoft Root Course they'll do is they'll look at the GPUs. So graphical processing unit. So small tasks will be happening. So we'll have to fetch the API, we'll have to fetch the details from the Tor, all this. So what happens is we'll be using graphical processor units so that they are scalable enough to perform multi-threading tasks in each and every possible way so that we get accurate data, so that the model is scalable and we get more and more data. And also, as Anushit sir has mentioned to us that if we give any, sir, we can make any chatbot or any portal which could be accessible to whole police department or to anyone. But that could mean that people might think that it has some privacy issues. So sir wanted us to make it just for the police professional who will be sitting within the department. So when that personal will extract the data and he will send it back in form of a PDF, which is PDF is the easiest way so that any police officer can retrieve the data. So if we investigate, sure, sure, sir. No, ma'am, it'll take time. Truecaller. So sir's mobile ID is only attached to Truecaller, not to the Instagram, not to the Twitter, not to any other thing. So data. So whatever data, even it is less, we are fetching it accurately. Hmm. Hmm. So, sir, what we have took the database is HLN, sir, which is a already cracked database, which is available on the online. So, with that, we will be able to fetch this database. If we have police, as Anshit sir was telling that they have a database. So, if we can get the database if police professional will be adopting our solution, then we'll make sure that we'll take that database and then we'll do all the processing, and so that it will work well, sir. So that if you have the because sir's mobile ID. Yeah, ma'am, you can confirm it. We can confirm it with sir that they were the false tanks. Yes, sir. Yes, sir. So we fetch the accurate data. So like whatever it was related, we fetched it. This yeah, it's because yes, ma'am. Yeah, ma'am. Hmm. Yes, ma'am. Make sure that it happens. And also the web search. So if we see one, so that's why we made sure that it is yes, yes, sir. Yes, sir. Hmm. Yes, sir. Yes, sir. Hmm. Hmm. Yes, sir, exactly. So for that, sir, in order to get the accuracy for machine learning model, we need a data set. So now I can just, we don't have any data set at present. I can just use some dummy data set and then I can get 85% to 95% accuracy. But if the more the data portal will be used, the more data will be scraped. So with that, we have integrated a Postgres. So all the data will be stored in that. So based on that, if they use 3 to 4 weeks, no, sir, we'll get lot of data so that the machine learning model will be trained and that will give the accuracy. Yeah, ma'am. And one more is web search, ma'am. One last thing. So what happened is we are using the web search portal. So there will be a criminal. He will be associated with previous some crime he might have done, right? So we will be fetching the news articles of that particular criminal wherever he is for the past 10 years. That keyword will be matching. So we have fetched Anuchet sir's ID. So we can see that search when sir was joined, everything, all the.
Yeah, thank you,
Thank you.
Team Breakpoint. With this, we move to the last team of crowdsourcing of records, Team Control Alt Elite from Bangalore.
Good evening, everyone. We are students from Engineering, Bangalore. Today we are here with a solution for crowdsourcing of records. So going to the demo directly. So the first thing that our application can do is find linked accounts, right? So like we can give like first is email ID. Anyone. So I think it goes to various accounts, whether or not mobile number is linked to the account. So he said earlier that he made it private. Yes, sir. You made it private. Yes. And so we've done the same thing with the email ID as well. So you can get whatever accounts are linked to a particular email ID as well.
No, no. What is your result? Your result is the idea thing gave at least one something. Yours is zero.
Yes.
Zero
So
matches.
Truecaller didn't come for us. But we had lots of other fields, but Sir didn't have for any of them as well. No. Yes, sir. From various social media accounts as well, using the username, and we were able to generate the record and download it as a document form. So we will be able to show you that. So should we show it for email ID? Yeah. So maybe you made your Twitter account using your email ID. Can if you give me your email ID, it might show true if you have a Twitter account. So it gives the account you use to register for the social media, not like so if you registered using your email ID and later you add your number for recovery purposes, it will only show true for email ID and not mobile, but it will show true for email. It won't show true. account is showing from here. So we take it to our social media today for now. So we can't get the username is the only way we can find a user on social media. So that we can only get through PNC and it will never be 100% accurate. So we didn't go to get there. Anusik sir had mentioned that they only approach the so we're able to collect it from a larger source of data and present it in unified manner. So you don't have to go through everything separately. And it's also in a human readable, like easy to read form. So like we do have web scraping as well, which will return the publicly available data. But we know police has more power, so they can directly approach the organization to get more details. So this shows like which organization they can approach to like get links.
Yeah, see, here you have written Twitter true. Now I want to go to next step. What is the basically ID or the this profile? Can we go?
So if you give the username, then we can get a lot of information. But in the username,
You have got only email ID now. Okay, so with the email ID, your search result is showing that true for the Twitter. Now with that, you please go to next step and show the profile of Twitter.
so
Link
we
to
won't
that.
be able to get the Twitter profile, but we're able to get the LinkedIn profile and get the data from LinkedIn and get an location.
Please do that then.
Yes, sir. Yeah, sir. So we don't have a LinkedIn link to your account. We will be able to get the Skype forward. So we have a link to your Skype forward. So, but if you give your username for any of the social medias that we have listed over there, we generate a Word document of other information. And it automatically gets downloaded to the platform, so it's easy to look through all the data at once rather than going through separate data. This is the one we got for Instagram with the username again. We can get all this information: biography, follow, following count, business, professional, join recently. Uh, and profile photo and if it's connected to FB or not. This is the data we got from Instagram. This is the data we got from Facebook. User ID, username, URL, cover photo, and these are the last four posts. So we get the link of the post, the link of the image, as well as the link of the caption. So this will help create the digital footprint of any user. So similarly, we're able to generate reports for each of the social media based on the username. And then we also can generate a combined report, minimizing all the repeated data that we get from different social media and combining different data that we get from.
Thank you, team Control Alt Elite. With this, we come to the end of crowdsourcing of records. Now, moving on to the final problem statement, which is unified data. We have the first team Hack Overflow from Coimbatore.
So, yeah, greetings everyone. This is Team Hack Overflow, and we are. So yeah, so we have developed a unified data portal for United Policing. So first I'll tell you like our prototype will be of three objectives. First objective is we have replicated the real-time websites, the portals of state government and national government, which is holding the actual database. We were given only Excel sheets which contain sample database. So what we did is with those sample database, we have replicated the existing website so that from there we can access from there we can access the endpoints through API calls. So from there we can integrate to our portal, making it production ready. So in future also, if you want to integrate our prototype with the existing state government portals, it will be easy for you. So this first for login, we are using two kinds of authentication, which is one is token based, the other one is cookie based. And once you log in, this is the ICGS portal, like a replication of the existing ICGS portal. You have certain filters there, and you can, by applying the filters and whichever data is required for you, you can filter it out and scrape it here. So what we have done is, like this, we have separate three portals. From those three portals, we have replicated them, made them as API endcalls, and from those endpoints, we have integrated to our websites. This is our prototype, which we have developed. Over to Bhunesh.
So our prototype first consists of a search option. Search option consists of name, search input type, as well as multiple filter options: name, arrest date, gender, state, etc. So we can specify the filters and we can search the data. So once the data is searched, it scrapes from two different uh, representations of portals. One is ICJS portal and another one is state portal. So once the data is scraped, we can actually expand the data to view more information. We can even export the data, which actually shows the entire search results of the search results of.
We have created data from those Excel sheets and made it as API endcalls, and we are using so that this portal can be integrated with the existing portal. We cannot access the government portals, so
We
we
were
are
not-
making it production ready.
So once the data is exported, all the search results will be in a CSV format, which can be easier for further processing. The next one is fingerprint matching. So due to constraints in processing time, we recorded it as a video. So
No, sir. What we have done here is we didn't use an actual fingerprint scanner. We used a mobile phone. We have developed this and we have made it as a backend part. So we have used the already available like the data sets we have given fingerprints. With the help of that real time, we are using a camera to get the fingerprint of the user. And from this and the given data set, we'll be comparing to find the matching results. How much approximation is given. So we have recorded so that the time will not be consumed.
So once the fingerprint is captured, it is cropped into the specific fingerprint region, and it is converted into an optimized version of where fingerprints is easily visible. And once the fingerprint is upscaled and monochromatized, it is compared with the existing fingerprint samples. So here you can see it is returning as ashwin.bmp, which is the file matched with this fingerprint, and this is the score of the accuracy of the matching.
So we're using an algorithm called SIFT, so in which there will be a patterns created for one algorithm, and it will be based like on the distances between from one point to another point and the angles, and then based on this, next provided fingerprint will be completed, um, and then it will be compared, and best accuracy rate will be written as the output. So. Yes, sir.
Ridges, roofs. So based on that, and it has to be 9 out of 10 matches.
Okay.
For any match to be positive match according to established standards.
Okay.
How does your this system work on that parameter?
Actually, it provides more than 80% accuracy, 8 out of 10.
The algorithm which we have used.
So we are using something called scale intermittent matching. So we are just analyzing the feature points of interest from all these fingerprints, and we just try to match according to the angles of the fingerprint area and the distance between 2 points. And things. So there was a research paper based on this, and most of the fingerprint sensors are working on this concept. But we wanted to try to replicate it with our mobile phones because we had some hardware dependencies for the. Yes, sir. Yes, sir. It is 80%, sir.
It depends on the angle of the finger. It depends
Yes,
on multiple factors. It can.
Also depends on the lighting and everything that is surrounding, sir. Yes, sir. Yes, sir. Yes, sir. So we also have an OpenCV wrapper which is doing it, sir. So the accuracy was. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Sure, sir. Yes, sir. So we also have a facial recognition algorithm. So we can just show you a quick hands-on demo of it. So, so I can just see that it is classifying her as Ashpati because we just trained a convolutional neural network with our images. So it just classifies it as Kumar Guru for me. And then for Ashwin, it's Ashwin. So we use a convolutional neural network built with teachable machine for this hackathon. So we just have a data set of just 4 people, but we can ensure that the accuracy will remain the same when the data scales up. So we also have interfaces developed for this.
Search in that, you go back to the last slide.
Yes, sir.
Search Manjappa.
So is the spelling
Spelling that dynamic here you have to, because Indian names can always be spelled for that matter all names.
Yes.
So that phonetic here should be there.
Yes, sir. We'll definitely have this on notes.
So you try it out, MN, J, PTA, or one or two other combination you see. If any such result is
Yes, sir. Sure.
See the right side go up, come down, come
Yes.
Not Manjappa. That is the only common, all the common.
What's that, sir? So
That's what I asked.
yes, sir. Yes, sir. So for now it's just word search, sir, but we'll try to go more deeper.
No, you have been given a very small data set.
Yes, sir.
And I asked you this Manjappa particularly because that is one name which is available in different data sets. But your search is not showing up any match, even in one data set. Forget about both data sets.
Yes, sir.
Actually, the search should be done on the ICJS portal and the
city portal. It is in both all the portal database. It is
So
there.
basically, it is not elastic. It is not.
Actually, we don't have direct access to the databases. State portal or
This is the data set which has been given to you. In that, forget about your database. Database, the entire database, it has to be scalable. But with a limited data set only, it is there, which is your system, your search is not catching.
Okay.
So your search is not working at all.
It's actually
See, look at the second one. It says Basavraj Manjappa. Second one.
So this is father name.
So we just have a few fields.
Basavaraj. This is father's name. We search only for name.
When a name, other's name also there, na? You could have searched for that.
Okay, sir. Got it. We only implemented it for name. We didn't implement it for father's name and mother's name. We didn't match with father's name and mother's name.
No, Basavaraj.
Not here, in Excel, not in Excel sheet. In your program.
No, you won't have the original data set to see and type in. No.
The spellings are
So
the problem.
it is not politics.
Okay, we got it. We got it. Thank you.
It doesn't take.
Anything?
Okay,
Anything?
fine. Thank you. Next.
Thank you. Thank you.
Thank you, team Hack Overflow. The second team for unified data verification is Octavian Cradle team.
So since our it's coming right? Yeah. So since our project topic is unified verification view, so our literal application is single app.
Mike. Keep it near the.
It takes some 2 seconds. Just hold on. Yeah.
Hello. Yeah. So since our topic itself is unified verification view, our entire application is literally a single page. So this searches all the 4 databases. So right now it's blank because the search itself is empty. So if I enter a value, any value like a district name or anything. Yes, sir. Enter Basavaraj. Basavaraj.
Yes. That's all.
Yes, sir. Enough. No. Wait. Search. So this is actually searching for all the columns. This is not limited to any one column. You can enter value from any column and it will show you you can test it on any columns of your choice. So here it's a Basavaraj. So all these columns have Basavaraj in some place. Basava, that's spelling in some place, in some column. It's there either. So it's there Basava, then in second, it's there in all of them. It's there. Sorry, yes, first one, you can see those values. Sir. It's there. Then it's somewhere it's there in those. You can see here, all these values. It's there. So it's searching every column. You can also enter the age as an integer and what's over here also. What's this? So
sounds like sir, A out. If I just search for BSA, is there some sounds like sir? Yes.
BSA.
Oh yes, say the spelling.
So spelling wise, it's not you get. But every column, every single part of all the 2 databases, central. Yes, sir. Matches exactly. Yes. Not the spelling wise, not single. So, but it maps all the columns and both the central and the state data. Okay, sir. So that is one, and also you can use crime. Or you can put a.
How are you linking the database? Because we have two silos.
Sir, we actually posted. So we took the Excel sheets and posted them into separate databases on this Azure. All of them are in different tables. Central is in different table and the state is in different table. Then when we are calling the search, we're individually taking the data out of them.
Problem why this
Yes,
problem statement was there?
Yes.
Because there are two
Yes.
you have to actually get a link created
Yes.
and then do the search.
Yes.
So now there are two different databases. So you have to have that bridge. So what have you done for that bridge? Now here you had a small data set. You just uploaded it in one single Excel sheet and did it. That is not going to work in real time mode,
Yes.
isn't it? So what is, have you worked anything on that? So that is the main solution. Otherwise, this is a simple thing. Put it in one Excel sheet and such.
Sir, we have taken the two data sets and uploaded it into two different databases. It's not in the same databases. So first it will search in one database. If it gets a result there, it will print here, and it will search the other database and check for the same.
What is the bridge?
How have you done it? Can you explain?
What is the bridge that
So
here it was basically given?
yes. So there's a Python library called Pandas. So we have used that to merge both the data sets.
So it's a brief process. So first we created a database on Azure. Okay. So then we converted these Excel sheets into CSV files, then uploaded them using data grip software. Separate. They are completely different tables. One table is called Karnataka State Government. Another table is called CJW, whatever the central data, ICJ's data. Okay, sir. And when we're doing this search, we are making individual call using a pandas reads SQL table. Like there is a function called method called read SQL table. You individually to both the tables, and we're taking the data out of them and searching these columns, sir, all the columns. Since the schema is the same, all schema in both the tables is the same, sir. Absolutely.
You search for Basava, right?
Yes, sir.
Will it display Basava from the state and the ICS together?
Yes, sir.
With all the columns and the tables. Have you created that? Have you basically joined both the tables together?
What he's telling that is there a segregation of the that the first 10 which have come matches have come from police IT. I mean the state database. The next 5 to 10 say have come from the ICJS portal. Have you done that? This is what he says.
Yes, ma'am. We have, ma'am. Actually,
It is true.
we have joined the two tables, ma'am. We have joined the whole thing to search for elements. Search for
What
elements.
you can do?
Sir, anything, sir.
Anything of done.
Sir, you can search place also. Search place. Search a place like Mysore, Delhi.
So fingerprint.
So fingerprint will show this. One second. Yes, sir. One second.
So if I search for number, search for the so wherever
You have the fingerprint of anyone?
Yes, sir. Yes, sir. Yes, sir.
The fingerprint we have.
So the data set we used was very small, so it will be a bit faster.
You had given a small data set.
Yes, ma'am. It was small, very small. Maybe 10, yeah. Yeah. And if you click on search, yes, sir. That is the data that matches with that guy, and it will be displayed in the same table itself.
And you have taken that out, you can go back to Excel sheet.
Go back to the.
You show me the Excel sheet from where you took that.
I say, sir.
How come I come in this colors of
Sir, we created a dummy databases out of this. So we just took a few of these fingerprints and created our own Excel sheet because there was no name related to any of those data.
No, this one.
Yes, sir.
File connected to that name. What is that number? Can you see any reference number here? This image, fingerprint,
Yes.
is going to that Excel sheet and
Yes, sir.
taking
Yes,
out.
sir.
So why it is going to that Excel? There must be some connection.
Oh, yes, sir. Yes, sir. These file names have actually been stored in a database itself, along with the details of that person. Yes, sir. Yes, sir. This was the database we used. This is the only small set we have created.
No, that file number I am not finding here.
Set is at the end.
So
We have to stop. We have to store it. Yes, that's the fingerprint data that we have.
This was given by us.
Yes, sir. Ma'am, yes, ma'am. But the data set belonged to not Indians, it was African data set. So we had to do some adjustments. We had to create our own data. And ma'am, those are
the last one was the.
Yes, sir.
What was the last one?
This one.
Last one. That was the data set. That was the name.
Yes, sir. That was name of the file, sir. .dm. Exactly, those were the data files.
So click on it. Can I see that fingerprint?
So that it won't show the fingerprint, it won't show the file names. It's only the name of the file. Name of the file. So to see the file, you have to go back. These are the
Fingerprint is coming.
so these are the real images.
So this is the preview of it.
Preview of the image. So the data we use itself was so small because it was extremely limited to get this information. Or for same schema. Sir, and the next one is
Now, if I have to deploy your solution tomorrow in our databases, the database here you have a set of 10, 20. There is millions of here.
yes.
How can it be done?
Sir,
What is the scalability and what is the practical reach solution that you are provided for?
Sir, right now the
Yeah, what will it
yes. Sir, right now the library that we have been using doesn't rely on
cannot create a library because there is a live data set and the data set is so huge that you cannot create a library here and local cache you cannot create. It has to be live search in the database.
Sir, actually these results that you're right now seeing are actually from that.
This is what you have been given one page data set.
Yes, sir. Yes, sir.
We have done. That is
Yes.
not the solution.
Yes.
The solution is when it works on millions of data. It's a huge database
Yes.
which you cannot create a library and keep it download in your system
Yes.
to do the matching. It has to be live matching against the database. How does it work?
That should see. Sir, that exactly is what deep face is meant for, sir. It does not rely on passing us. I mean, continuously giving data and building the basic library.
So all these things, all these databases we have deployed on Azure. So in the future also for large data handling we can deploy there, and we are using a model called Deepface, which is a Python library. That is a combination of 8 other face detection libraries. So it is used to process the images, the face images.
How can it? You're right. Yeah. It will be API.
API.
So it has already been trained on millions of. So it is a combination of 7 plus different models.
The question is different. Like the actual database is different.
Yes.
What do you mean? The actual database is already. It's okay. I will get this. the columns maybe have to add.
Okay, thank you.
Thank you, Team Octavian Scraddle. With this, we move on to the last presentation of Police Hackathon. We have Team DataZip from Unified Data Verification. Team, please.
Hello everyone. Good evening. So we are the team DataZip. We are here to present our application for unified data verification. So this is the application. I would hand over to my teammate to.
Am I audible without the mic also?
Yeah, you can use the mic either way.
So yeah, hello everyone. We have built a unified data verification platform, and the whole front end is hosted on Azure Static Web Apps, and we have used React.js for the UI, and then Firebase for the authentication. So once we log in, we are greeted with this UI, and we have a search field, and then we can choose the fingerprint image and the face image. So let me go ahead and give a name now.
Shall we set the one?
Yeah.
So yeah, we got the results for the search term which we gave, and this is a completely dynamic search. A single field will accept up to 10 parameters. You can search for like father's name, permanent address, district name, state, and all. And along with that, we have given another two options for advanced search. So if I click on this, I'll be shown to this specific area. So let me just go ahead and choose some random data here. So if I give here female and then
Email will not be there from you.
26. So yeah, it will accurately search and then give us the results. So coming to the next part, we will upload a fingerprint image.
Sorry, could you repeat?
No. Just Panjama Jharkhand, just show which database is it. So, just the last one is Jharkhand. That from state it becomes Jharkhand.
So, sir, it actually with the fuzzy search, even if you do a spelling mistake or something like that, it always tracks that. So, if you see the spelling correctly, it's Manjamma, right? So, it's tracking that as well. Even if
Yeah. But when you are showing Panjama, against Panjama other parameters if you see, state it is showing Karnataka and Jharkhand.
Yeah. So we'll show you as with
if I instead of giving the gender as female, if I make it as male,
it is there, no?
Sir,
fine. Please go ahead.
So let me just go ahead and upload the fingerprint image. So once I have given uploaded the image and I'll click on search fingerprint, it's going to give the image name as well as the accuracy score of the image compared.
So basically, sir, this image is being searched from the 54,000 images that were given to us, and that happened within like milliseconds.
And then now let me go ahead and add the face image. So yeah, so it has identified the image name and then the accuracy score. And the same image name is going to be applied to the search field. So if I go ahead and search this, I'm going to get the data for that.
So basically, we have also facilitated the reverse search from the image. Like the image is there, and then from the URL of that image, we'll be able to identify the particular
fingerprint previously, and you got the exact name, that fingerprint. Only one.
So in the fingerprint database, we were not given the mapping to a actual culprit database, but in the image database, we were given. It was the data set that was given.
All are given different addresses. ID is being reported. Fingerprint ID is being reported. It was not associated with the name.
It was not associated with the criminal record.
ID or name.
But images were associated, so we were able to do the reverse with the images.
So can you the fingerprint once more?
Sure.
Yeah, sure, sir. So I'll just go ahead and create this fingerprint image. Then if I click search fingerprint, it's going to print the picture. So let me just go ahead and oh yeah.
Okay. Maybe just go to the Kaggle. So what we'll do is we'll go to the Kaggle, which the dataset was provided, and use any of that image, it will exact match that image.
Then we will take some random data.
It's an exact match. So for the this dataset, fingerprint dataset, we were given the instructions to do an exact match, like a 99.9%.
So
Yeah, what time of data? What's the how they have you taken?
Yeah, so we have made sure that this scales to billions to billion rows. So first of all, we have used Elasticsearch for the searching part, right? Which is the most crucial part of this. Even if you had multiple parameters like a person, name, state, or let's say his gender, all of this would be searched in one single query, right? And we have also prioritized. Like for example, the person's name is the first most highest priority. So we have calculated that score based on his name, and after that, what comes like state, or what comes like his district, or maybe his father's name, something like that. So we have given the score to each of the parameters, and based on the 10 parameters, you can actually do a fuzzy search as well. Like even if you type the all the data, yes, Elasticsearch. Yeah. So one of the most important factors that I felt that was missing was the data ingestion part, because obviously the data is going to be updated regularly from the department, right? So we have also have a data ingestion as well. So we have built it on an open source framework. We'll also like to show.
just upload this. Sure. So I just downloaded a new from the Kaggle dataset.
This is a random image that we have downloaded from the dataset.
And if I just go ahead and search it,
yeah, it's right.
Yeah, it got updated.
So this actually happened to 55,000 images. And so let me take one and quickly show you.
Only below names.
No, the fingerprint is not matched to any names because by the dataset which we get.
Yeah, it's a file name we are showing, but actually we are matching images.
Show me go to instead of fingerprint, go to image photograph.
Sure.
Photograph will show me the name.
Maybe this one. So this is a photograph of Shivanna, right? And the photograph we can actually reverse that to the records. So if you like, search here, you will get Shivanna, all the matching to this image.
So it's a name-based search.
It's a URL based search. If the record matches to your image, we use that image and reverse the criminal's ID. So, and apart from this, we focus on data.
Which you have entered is a particular person. Why it is resulting so many same names?
So because like it's a Shivanna, right? It's a fuzzy matching. It could be
Today, which was before, was for a particular person. It must result that.
so the top person that you see, right? He's the top person.
Other names are also there.
But image matching is every like it's not a clear match, right? It's a percentage on image match. So we match it based on whatever the best we get. So the first person is definitely the person who is being matched. And apart from that, like, do you have any further questions on this? Yeah, I will tell you the ingestion. Yeah, quickly, right? So ingestion, because police department have multiple departments. Like Karnataka is the one, ICDS is the one, Kerala is
So there could be multiple databases that might be being used, like MongoDB, Postgres, MySQL, or any of the other databases, or the data could be in the files as well. For example, CSV files, or so we have we have also an open source project, and we have built on top of it, like it supports 150 plus connectors, 150 of different type of sources, like for example different databases, SAS tools, files, right? And once you basically connect all of these sources, then you can dump the data into the search engine and search on top of it, and it regularly dumps the data. Like every day, like if you see here, we have dumped the ICJ to Karnataka.
Single database with all of the.
Yeah, so it will help you unify all the data into one place and search.
You change in data.
Yes. So it updates the data as well based on the data.
And you can set the frequency also, like how
So, yeah, would love to inform you about the ML model that we have. Yeah. Go ahead. So basically, what we are focused on is both scalability and also the latency. So for scalability, we have used ML Studios, where we have pre-trained with existing very deep convolutional neural network. And what we've done is from the datasets that we have provided already, or from the datasets you actually have, this will run when you move it, and it will actually be ML2. So we use the Azure ML Studio, and we use Azure ML Studio. I have not developed anything. No, no, we have used existing tools. This is a package that's a image studio. We have used that one. We have used that. So to run the model, we use the image studio. Instead of using the local host, the model is also run there. And from there, we get the output of the feature maps and also a server which is there. Model we use VGT16, which is a internal model which already has feature extraction. It's an existing model, but we make sure that we are actually mapping the features and not imitating the old model every time. So what we just map the, like we take features once and we just map them later. Okay. So anything else?
and along with that, the whole application is deployed already, and it's completely mobile responsive. Even we can use our mobile system to enter the data or search the results.
Thank you.
Thank you.
Thank you, team Hackathon. This was the last presentation of the day. Kindly be seated at your places. We'll be back with the winner announcements in next 10 minutes. So kindly be seated. There's snacks after the winner announcements. So please be seated over here.
This. All the participants, we request you to kindly collect the certificates now. This is the participation certificate. If you guys are chosen to be winner, then you will be getting another certificate also.
सिर्फ ये पॉज करना लाइव इवेंट पॉज करना है ये यहाँ पे ये लोग हैं करना है पूछ रहा हूँ guys there is still live going on, can you please move to the other side if possible? Yeah, you are in the picture. Live video is going on YouTube. Adarsh, live YouTube live ನಡೀತಿದೆ ಅಲ್ಲಿ ನೋಡ್ಕೊಳ್ಳು.
So the whole thing was streamed on YouTube.
Yeah. That's what police hackathon. I didn't. I have no clue. There were people who joined from the police. There was around, if not the last semester, it was 119 views.
That's pretty good.
Yeah. ಹೇಳಿದ್ರಾ ಲೋ ಮತ್ತಿದ್ದು ಪ್ರೆಸೆಂಟ್ ಕೊಡ್ಬೇಕಾದ್ರೆ ಲೋ ಪ್ರೈಸ್ ಕೊಡ್ಬೇಕಾದ್ರೆ Don't do it. Put them around the camera. I think they are
This is the camera. See.
okay, okay, see.
This one is the camera. Go stand here.
Okay, camera. There are 12 views, not this one. Now we are streaming for 4 hours, 40 minutes. Okay, okay.
Do you want? I can ask Prince to get it. Is Prince not what? Where's your tablet? Others can get.
Others?
Prince.
Others?
There is so that's the class corner, the corner. There is a red above next to
Dark procrastination. Dark procrastination.
What?
Team Darkside Assassin. Team Darkside Assassin.
Where is Sagar?
Hello, hello.
So something 10 minutes. Yes, 10 minutes. You should all be out of here.
Very fast. All the jury there.
Yeah, they all.
Hello, everyone. Hello. Hello, hello, hello. Can I have some attention, please? Hello. Guys, we have the results, so I request everyone's attention, please. So we'll be announcing the results. I'll request all the jury members to join me on the stage.
I know.
Sir, please.
Yeah.
आप इधर आ जाइए अदरवाइज हेलो हम संतोष
I'll do from there. Yeah. So, may I have your attention, please? We are here with the winner announcements. So, for the first problem statement, unified data verification, the winner is Team DataZip. Congratulations, Team DataZip. Could you please just join us on the stage?
Two of you come this side, two of you this side. So no, you are giving the source code, no, you are supposed to. Then it is fine. We'll work.
For the next problem statement, okay. So there's a special mention in the problem statement, unified data verification, and a special mention team is Hack Overflow. Could you please join us? Yeah. So Team Hack Overflow gets a special mention prize of rupees 10,000.
Special mention.
Thank you, Team Hack Overflow. The second problem statement, the winner for problem statement crowdsourcing of data is Team Breakpoint.
Take this.
For the next problem statement, AI face detection, the winner team is Team Code Wizards. For the next problem statement, bank account analysis, the winner is Team Elysian. For the final problem statement, fraud app detection, the winning team is driven by data. Thank you, everyone. Thanks a lot. And thank you, Sumendu sir, and the entire KSP team for giving us this opportunity. Sir, any closing words from you?
I must thank all the participants. All of you have been really wonderful. It was a fabulous experience. All of you are really talented. and I wish you all the very best in your career. It was just that in these 30 hours, some of you did slightly better than others, but all of you are excellent guys. All the very best.
Thank you, everyone. Thanks a lot. With this, we close the 30 hours Karnataka State Police Hackathon. Thank you, everyone, for joining us.
Yeah. 12% are saying okay.
Your team, others are also telling me.
We are like a thank you,
Thank you. Thank you.
Thank you.
It's
not done.
It's not done. Possibly, thank you. Thank you. Thank you. Thank you. But, thank you.
Special message. Thank you. Thank you.
Thank you for everything.
Yeah.